as an arrow function, and I can put in my, let's say, prev things array, or I could simply say prev state if I wanted to. I'll keep it as prev things array so it's contextual. And now that I have gotten us this far, I want you to pause and see if you can figure out what I need to add or what I need to return in this callback function to correctly update my array with the new thing that I want to add. And if you remember, every time we click add item, we want to determine the length of the array and just add thing space and then the new length of the array. So it should automatically put thing3 when I click add item. This one can be a little bit tricky. If you spend more than maybe 5 minutes or so without figuring it out, you can just hit play again, and I'm going to show us how to do this. But I do want you to pause and see if you can figure this one out. Another really tempting thing to do at this point is to say prev things array dot push. However, again, this is not correct. This prev things array is still a reference to my existing state, and using dot push on it is not a good idea because that would be modifying state directly. Not only that, but dot push actually doesn't return the array that is modified. It returns the new length of the array. So this would be like replacing all of our state with a number, which would just be 3. So I guess in 2 ways, this really isn't going to work for us. Remember, I need to return a new version of state. And my state starts out as an array. In fact, my program expects things array to be an array because I'm using .map on it. So I need to make sure that when I'm setting a new array that I return a new array. This is a new version of state. Fortunately, with ES6, there's a really easy way for me to spread in my existing array, which I have access to with prev things array, which by itself would get me an array of everything that used to be in there. So this is not yet updating it. However, I can very simply add a new item to the end of my array. These are strings, but I'm going to be using some JavaScript to determine the array length. So I'll use some template strings here, and I'll say thing space, and then interpret some JavaScript by saying prev things array dot length. And because that's the previous array and it's not 0 indexed, and I want this to say 3, I'm going to add 1 to it. In other words, my previous array was 2 items long, and I want it to say thing space 3, so I'm adding a 1 at the end. This is getting a little long, so I'm going to put this onto the next line, which means I then have to use a return. And well, let's just see if this works. I'll hit save, add item. Awesome, look at that. We've got things adding to our list with the correct numbers and everything. If you're feeling hazy or forgetting the array spread operator and how this works, that's totally okay. Although I would recommend that you go study up on the array spread operator because it's so useful. You're going to find yourself using it all the time, especially in React. However, this isn't the only way to do this. There certainly are other ways to make a copy of our original array or to return a new array. We could even use a for loop that loops over this array and pushes those items to a brand new array. Then we add our string here at the very end before we return that whole new thing. Obviously, this is why I'm saying you should just go focus on learning the array spread operator because it's extremely useful. Okay, I do have one big challenge for you. Okay, it's time to put all the knowledge that you've learned lately together into this challenge. In fact, if you want an extra challenge, you could delete this line where we set up things elements where we're mapping. I figured because it's been a minute since we've looked at this, I wouldn't necessarily make you do this, but if you really want to challenge yourself, you can delete line 13 here and try to do everything completely from scratch. Like I said, I'll leave this here just in case that's a little too much to bite off at this time. So see if you can build this all again from scratch. Let me refresh this so we start from a new spot. Of course, this is broken because some of the values are missing. Pause the screencast and see if you can bring this back to a working state. Okay, let's do this. I'll use things array and set things array as the values I get back from react.useState. I'll initialize my values with thing1 and thing2, and I need to spell things right. Then we will use set things array using the previous array. I could say previous things array or previous array. Maybe this time I'll be a little more generic and just say prev state. And this will return a new array that has all the items from prev state, as well as a new item which says thing space and then the number of prev state.length plus 1. Of course, if I leave this on the same line, I don't need to open curly braces and use the return keyword. Just in case this is bleeding a little bit long for anybody, I am going to put it back that way. And hopefully this didn't drive too many of you crazy. You can see I refresh and everything comes back. I also had taken this on click out. Sorry if that threw anybody for a loop. I'm going to add it back in and say when the button is clicked, I want you to run add item, which will run the set things array function and do all the stuff that we just typed in there. I'll hit save. Awesome, we're working again. I really hope that you attempted that challenge. I know that might have been difficult, but truthfully, that's where the learning happens. You won't be able to truly internalize these things that we're learning unless you put your hands on the keyboard and really challenge yourself. In fact, I would say that as you come to challenges in this course and really any course on Scrimba, if you don't immediately know the answer, don't just hit play. Go to Google. Ask the community. Go back to previous lessons in that course. Do whatever you can to try and figure it out on your own. And then, of course, if you are completely stuck, you can always hit play. In the next cast, we're going to see something similar, but working with objects in state instead of arrays in state. Now let's see what it looks like to use an object in state. Here we have a simple contact card. It's got a first name, last name, phone, email, and a property called isFavorite. To kick us off, I want you to see if you can figure out how you might fill in some of these values below instead of using the hard-coded values, using the properties from state. Of course, they will look exactly the same because I just copied and pasted these values from the state up above, but you can always test it by changing one of these values in state and seeing if it reflects on your card there. Pause the screencast and work on this challenge. Let's start with the name. We have the first name and last name together inside the same H2, but they're separated in the state up here. The simplest way to do that is simply to put the first name in its own set of curly braces, put a space, and then the last name in its own set of curly braces. Now, because my state is an object, I need to reference the entire contact and then use the dot syntax to access its properties. So I will say contact.firstname, and then the space, which will be interpreted as an actual space in the markup, followed by contact.lastname. Hit save. Nothing looks like it changes. That's good. If I change this to Jane, our contact changes. Great. And then I can simply do the same thing for these other properties. This is contact.phone and contact.email. Now, I mentioned that we're going to ignore the isFavorite property for now. I have another challenge that I'm going to type out now. You might notice in the images that we have two separate PNGs, one called star_empty PNG and one called star_filled PNG. Right now we're just using the star_empty PNG, but if this were filled, and let me comment this out so it doesn't break our code, you'll see that it fills in the star nicely as if this contact were a favorite of yours. However, following the declarative nature of React, we want the isFavorite property to be the determining factor as to which of those two images gets used. So your challenge is to use a ternary right here in this line. I'll uncomment this now, to look at the contact.isFavorite property and determine which of the following file names should be used based on the value of the isFavorite property. Then you'll want to use that star icon value, which will just be a string here, to figure out what the source should be for the star image. In fact, I'll add that to our challenge. Okay, best of luck. Pause the screencast, work on this part of the challenge. On line 21, I'll replace this comment and we'll simply look at contact.isFavorite. I technically could equate this to true or false, but because it's already a Boolean, I just need to say contact.isFavorite. If so, I want to use the star_filled PNG. And otherwise, I want to use the star empty PNG. And now that I have a value for star icon, I can simply replace whatever is here with star icon. You'll notice I had put backticks here to begin with just to make things a little easier. That's because I knew you were going to be putting in an interpolated value like that. I'll go ahead and hit save. Everything looks the same, but now if I change my isFavorite from false to true in the hard-coded initial value, we get a little filled star. Now that we've learned how to apply state that's in the form of an object to our actual markup, in the next screencast, let's learn about how we can update state when state is an object. Our goal is to be able to click the star icon and have it flip our isFavorite value from true to false or false to true. However, currently, our isFavorite property is nested inside of this object. When I call setContact, I need to provide a new version of state to replace the old version. However, in our case, I don't want to replace any of this other information. I only want to change the isFavorite value. Many people's first thought is to use setContact, and here you'll see I already have set up a toggle favorite function, which is called anytime the little star icon image is clicked. Right now, it's just console logging toggle favorite. A temptation is to use setContact, look at the previous contact information, and return, and I guess for simplicity I'll put this on its own line, we'll say return an object where the isFavorite property is the opposite of the previous contact's isFavorite property. However, there is a major problem with doing it this way. I'm not going to hit refresh yet, but I do want you to pause the screencast and see if you can figure out what mistake I have right here. Remember that in this callback function, whatever I return from that function will become the new replacement for our contact state. Currently, I have an object with 5 properties: first name, last name, phone, email, and isFavorite. But what I'm replacing it with is an object that only has one property, isFavorite. So if I hit save, and then click our toggle favorite, you'll see that all of our other information just disappears. However, it does look like our star is working. I can click our star and it is correctly flipping back and forth, but obviously this is a bug. If you do happen to be coming to this course having had experience in class-based React, this might seem confusing to you. If you've never worked with class-based React, you can ignore the next thing I'm about to say. But in class-based React, when you use this.setState, it would automatically figure out how to combine your old object with the new property that you're trying to replace it with. However, using hooks with react.useState no longer does this. Okay, everybody can tune back in now. The main point is that I need to make sure that I bring in all of the properties of my old object and then replace the 1 or 2 or however many properties you need to replace in what you're trying to accomplish. A very simple way for me to do that is to spread in all of the properties of my old contact. And in this case, I have access to the old contact using prevContact. So I'll bring in all of the properties, and this, by the way, does include the isFavorite property, but then I will overwrite the isFavorite property with a new value. In effect, it's like taking this whole thing, copying it, pasting it in, just like this, where we have our old first name, old last name, old phone, old email, the old isFavorite, and then we're saying, actually, I want a different isFavorite. Believe it or not, this is not a syntax error. Instead, it just takes the second one that's declared, or rather the last one that's declared, and uses that as the actual value for our new object. This is much more verbose than it needs to be, so I will use my spread operator instead like I had before. I'll hit save. Notice this is filled in because my value is true by default. I should probably set that to false by default. And then when I click it, all of the other information stays the same except for the value of isFavorite, which is then redetermining which icon is going to be used based on that contact.isFavorite property. I totally understand that this can be complex. This was one of the more difficult things that I had to grasp when I was first learning how to do state in React. So to see if you were paying attention, this is your time to shine. Your challenge is to simply rebuild what we just had. Again, if you get stuck and you don't remember the syntax, don't just hit play and watch me do it. Open a new tab, do a quick query on Google, see if you can find a resource that will help you figure this out, or even go back earlier in the screencast and see how I did it so that you can then come back to this point and type it out yourself. So pause the screencast and see if you can rebuild our toggle favorite function. Okay, let's do it. We're calling setContact. We do care about the previous value of our state in order to help us determine the new one, not only because we need to know what the value of isFavorite was, but also because we want to make sure we maintain all of the other properties. So in that case, I'll use my callback function. I'll let it pass prev_contact to it, and I will use that to return a new object. And here's actually a quick aside. It might be tempting to say, well, I just want to use the implicit return and say, take this function, return an object. However, these curly braces are being interpreted as the opening part of the function body. If I do want to literally return an object, I need to surround my object with another set of parentheses. This looks a little bit crazy. Maybe just to show you that it works, I will leave it here, and for brevity, I suppose. So given our previous contact, I want to return an object that has all of the values of our previous contact, but changes the isFavorite value to the opposite of whatever it currently is. I'll hit save. It's empty by default because isFavorite is false, and I can toggle that on and off. I hope that challenge went well. If you felt like it was a struggle, then of course, as always, you can go back and try it again. As I've always said, the easiest way to learn something new is to do it the hard way. And I imagine some of you out there, when you saw me delete all of the code inside of here, maybe had a little panic moment and you thought, oh no, he's going to make me do this by myself. But your growth in understanding of React will only happen as you type this stuff out yourself. Watching me do it alone is not going to help you learn it. So as always, once you feel comfortable enough that you could write this out again all by yourself, that means that we're ready to move forward. When we last left the meme generator, we were getting a weird unknown error being thrown from React. I looked into it and I realized that it was because we were initializing state as an empty string and React was not taking too kindly to having our image source set as an empty string. So I just went and grabbed a placeholder image for now, and that seems to have gotten rid of the error. Just thought I'd give you a quick update on that error. Our challenge in this screencast is to update our state so that we can be well prepared as we learn more to save that state and ultimately finish our meme generator. So your challenge is to create an object in state. We'll call it meme, and it should have a property for the top text, bottom text, and the random image that we choose. You can default the top text and bottom text as empty strings, and I would default the random image to the string that I have below so that we don't get that same error we had before. Next, I want you to create a separate state variable called allMemeImages. This allMemeImages variable is going to hold an array of all of our memes data, which for now you can default to the memes data array that we imported up here. Then lastly, you'll want to update the rest of our code to use these new state variables so that in the end we have a working app the way that it's currently working. So pause the screencast and work on this challenge. Let's comment out our old state here, just so we don't get confused, and we'll create some new state with meme and setMeme equal to react.useState. And this one's going to be an object, so I'll put my curly braces, and we'll put in our three properties. We have top text, which is an empty string, bottom text, also an empty string, and random image, which will be the same as what we had before in our old meme image state variable. Then we need another state variable, so we'll create a new one. We'll say this is all meme images. And we can say set all meme images as our function here, react.useState, and the initial value is going to be our memes data array that we imported above. With those set up, we really just need to update the rest of our code. So anywhere I was directly accessing memes data, I'm now going to use all meme images. And then we have a bit of a gotcha here. Before, when we were just saving the meme image as a string, we were able to just completely overwrite whatever the old string was and replace it with the new URL. However, now the random image, which represents our new version of meme image, is nested inside of an object. So first of all, we need to use set meme instead of set meme image. And instead of what we had before, we do need to look at what the previous meme was in order to determine the new one, because we have properties like top text and bottom text that we don't want to lose. I think I'm going to save this as its own variable. So I'll say URL equals the memes array at the index of random number.url, just to make my life a little bit easier. And now I'm going to access the previous meme and return an object. I'll surround it in parentheses so I can use my implicit return. We'll pull in all of the properties of the previous meme, and then we will alter the random image property to be our URL. Let's scroll down and see down here we have onClick get meme image. That's still going to be the same because that's our self-defined function. However, here instead of meme image, we want to say meme.randomImage. And let's cross our fingers. We'll hit refresh. I can click get a new meme image, and awesome, we're working just the way we were before. Obviously, our top text and our bottom text is not yet doing anything, but we're first going to have to learn about forms and inputs and how to save state, which will be happening later down the road. All right, awesome work. Let's keep moving forward. At this point, we've learned to use a number of really cool tools in React like state and props. Now we get to start using those tools in creative ways and putting them together. Your challenge here is honestly pretty contrived. I can't think of a reason why you would actually want to do this, but for the sake of practice, I want you to create a new component named count, which will essentially replace these 3 lines of code. In other words, you'll create a new component named count. It will render this div with this h1, and in an effort to practice props, we're going to pass that new count component a prop that we'll just generically call number. The value of that prop number should be the value of our current count. I promise this isn't just busy work. We are building toward a point. Pause the screencast and work on this challenge. Okay, I'm going to do this working backwards. So my div here, I'm going to cut this, but keep it in my clipboard so I can paste it later. And I'll render a component called count, which I obviously haven't yet created. We said we're going to pass to it a number prop, and I'm going to set that equal to the current value of my count up there. Now I need to import it if I'm going to use it here. Obviously it still doesn't exist, but we'll just pretend it does. So I'm going to import count from a file called count, and then I need to create that file and work over there. So I'm going to create count.js, import React from React, and I'll just spin up my basic component here called count. And I need to make sure that this is receiving props because I'm going to use that number prop. I'll have it return, and then I'm just going to paste that div that I had before. Okay, and now it doesn't have a count variable anywhere in here. Remember, before this was referencing the state value of count, but now I'm receiving it through props. So I can say props dot, and it's not props.count because the prop we passed to it was called number, props.number. I'll hit refresh, and you can see everything is working exactly the way it was before. Now, as I mentioned, this is pretty contrived. I can't imagine why you would care to put a count component in its own component that just displays a number, especially when it's only 3 lines of code, unless for some reason you are going to be reusing this component in different contexts around your application. Let me clean up this challenge, and then we'll talk about why I had you do this. As I've mentioned, we've learned how to use props for a component to be able to receive values like we've done here. And we've learned state and how to have a component declare its own values that are intended to change and update the user interface when those changes happen. And now all we're doing is we're combining those two concepts. We are still initiating state inside of our app component, but then we're passing that state value down to a separate component called count, and it's receiving that value as props. Now we're going to see something cool that React does. Let me, inside of my app component, console log app component rendered. Anytime React creates an instance of our app component, which is happening here in index.js, it will run this function, and part of that function will console log app component rendered. Then we'll go ahead and do the exact same thing in the count component. And we'll change this to count component rendered. Now, before I hit refresh, as a reminder, the word rendered simply means that it placed the elements that React knew it needed to place on the screen. So when I say app component rendered, it means that it took the markup of our app component and it painted it to the screen, or it placed it on the screen. It created the DOM elements and the styles that it needed for it to display correctly on the screen. And you can see there's a sort of cascading effect here. Over in index.js, we render an app component. When we go to app, we see that it renders a count component, and it's doing that down the line. So it will first say app component rendered. I'll open the console and hit refresh. We see app component rendered and count component rendered. Now there's a really cool thing that React does for us, and that is whenever state changes, it will re-render the component where the state exists and any child components that may rely on state to be working correctly. And if you think about it, that makes sense. If I'm going to change my state from 0 to 1, I'm going to need my component here to re-render, which will then cause this count component to re-render, and it will pass the new value of count. And that way it can very quickly and seamlessly update what I see on the page just by re-rendering those components. We're not going to dive deep at this point into understanding exactly how React is re-rendering, which components it's re-rendering, and optimizing which components it's re-rendering. That's a topic for a more advanced course. But for now, it's a good experiment to have these console logs here and see that every single time we change our state, it's re-rendering the component in which the state is declared, and any children components like our count component here that may or may not depend on the state value for count. Awesome. Now we've seen an example of a child component receiving a state value via props. Now we'll look at how a child component might be given access to make changes to its parent's state. Okay, here we are back at our little contact card with the favorite icon. Your challenge to start us off is to move the little star image, just this one little image element, into its own component, and maybe we'll just call it star. That'll be the name of the component. And it should receive a prop called isFilled that the star component will use to determine whether the icon should display the filled PNG or the empty PNG. Then inside of this component here, you'll need to import and render the new star component and make sure to pass the correct value of isFavorite, our contact.isFavorite, to that isFilled prop. At this point, it's not going to work the way it was before where we could click it and flip it on and off. For now, in order to test it, you can simply change this value from false to true, and it should, if it's working correctly, display the filled in star when you change that to true. There's a few different moving pieces here, so this is a slightly more difficult challenge than the ones we've done up until now, but I know you'll be able to do it. Pause the screencast now and start working on this challenge. Once again, I think I'll work backwards. I'm going to cut this image out, and I will render a star component, which I have not yet created. I'll give it this isFilled prop, and it will be the value of contact.isFavorite. Let's import this, and then we'll go and create it. So I'll import star from /star, and then I'll create that file star.js. Okay, and in this case, I need to make sure that I'm receiving props because I will need them. I'm going to return, and then this image element. I'm going to get to this onClick in just a second, but for now, let's figure out our star icon. I'm going to just set star icon equal to, and then I'm just going to go take exactly what I had here and then make a slight change. Okay, now we don't have access to our contact state because we're not passing it down. However, we do have a replacement isFilled, and that's part of props, so it's props.isFilled. And then this will determine which image should be used. Let me remove my onClick so I don't get an error. We'll hit refresh and see if we missed anything. Okay, awesome. Now my star is empty, and that's because this value is false. Let's test this by changing it to true, and the star is filled. Awesome. And at this point, I can remove this line because I'm not needing that anymore. And at this point, that leads us to the topic of this screencast, and that is, how do I make it so that I can change this value? Clicking it is not doing anything. The conundrum that we have is that we have a child component that's receiving the value of isFavorite through props, but it is not receiving the ability to change that state. So think for a second, how can I give my child component the ability to make changes to the state that lives inside the parent component, which is app? In fact, I want you to pause and try to think through a solution to this. You don't actually have to type it and try it out, but just try to think, how could I give my child component the ability to make changes to the state that lives in the parent? One thing that can be tricky when you're first learning React is the thought that you can just add a click event listener on your star component. So what if I just said onClick equals toggle favorite? Let me hit refresh and click this, and you'll see, well, it's not quite working. Why do you think that this isn't enough for this to work? Remember, when we have a component that we created, a custom component that we created, all of the properties that we pass it are custom properties. So simply putting onClick here doesn't magically register it as an event listener. The onClick attribute needs to exist on native DOM elements like these ones that begin with lowercase letters. That's because these are what will actually get created into real DOM elements by React. However, star with a capital S is not a real DOM element. Instead, what's happening is React is looking at the star component and it's rendering this image. This image has the ability to receive an onClick event listener. So what I could do is still pass onClick here, but realize that onClick is just a custom prop that happens to be called the same name as the event listener. In fact, oftentimes this will be changed to handleClick just to make it very obvious that it's not a native event listener. And then over in our star component, I can add a real onClick event listener and say the value of this onClick will be the function that comes from props.handleClick. In this case, my app component is passing this toggle favorite function to a child component and allowing that child component to run it whenever a certain event like the click event happens. However, it's important to note that the context in which the toggle favorite function exists is still here in the parent, which means that it can change the state that lives inside the parent. Let's hit refresh. We'll click our star and we see that we're back to working the way we thought. So as a recap, we created our toggle favorite function, we passed it to our custom component in a custom prop called handleClick, and then over in the star component, it's receiving props and it's registering a real event listener onClick whose functional value is the function that we received through props.handleClick. The ability to pass state setter functions like this one down to children components is especially crucial in React. And that's due to the fact that the way that React's hierarchy is set up when it passes data. And this is what we're going to talk about in the next lesson. At this point, I think it's worth taking a high-level look at how data is passed from one component to another in React. Let's imagine we have a fairly simple app which has the following components, just represented by rectangles for now. In this tree, this top component represents a top-level component, for example, our app component in a system set up like this. And the lines indicate that this top component is rendering these other components. In some cases, that component may just render regular DOM elements like divs and h1s, or it may render additional custom components like we see in this box where it's rendering two other components. I didn't put any names on here because that's not that terribly important. The point is that there is a parent-child relationship between these components. Let's imagine on one of these bottom level components, we initialize some state. And then we find that a sibling component, in other words, a component that is also rendered by the same parent, is in need of some of the data that lives in the other component's state. Well, what exactly can we do then? Think for a second, is there a way for us to pass that state to a sibling component? It turns out that no, this is not possible. And that's because if you look in the file of a component that has a sibling component, it has no reference or knowledge about a sibling component on its own. If we look in our code here, we have an app component that is rendering a header component and a body component. But if we were to go into, let's say, the header component, we see that I've initialized some state here. I can open up this preview so you see what we're working with. And it's using that state, but then if a sibling component like the body needs access to that state, well, the header has no idea that body even exists. Only its immediate parent, app, is the component that knows that both of these components exist. So think for a second, what is it that we need to do if we're facing a situation like this? Well, what if we took our state in this child component and we raised it up into the parent component? Now that it's up in the parent component, do we have a way in React to pass data from this parent component to the child components? Yes, we do. That happens through props. So now the parent component is in charge of the state. It passes the necessary state down to the child components that require it, and they can simply consume the state. If that state were ever to change, React will update this component where the state changed, and it will also update any children components as well. And so therefore, if that state changes that's being passed through props, the child component can update as well. As your application gets more and more complex, you will find yourself having another component that sometimes needs access to that state as well. And just like before, there's no way for us to pass the state or any kind of data from one sibling component to another component, but it's also important to note that there also is no way to pass data upwards in React. This child component has no idea that this other, I guess you could say, uncle or aunt component exists, and therefore there's no way to pass data that way either. So this brings us back to the same solution we had before. We simply raise state up a level and we pass more props downward. Now, over time, this can get pretty tedious, especially if your state ends up raising up multiple levels above the component that needs it, in which case React does offer a solution to this called context. There's also third-party state management systems like Redux that can help solve this problem. However, both of those are beyond the scope of this course, and we are just going to be sticking with regular state and props for now. So that leads me to a challenge. I want you to take the state that currently exists only within the header and raise it up a level into the app component, and then pass it back down through props to both the header and the body. Then in the body, now that it's receiving the state from above, replace this underline with the state, which is the name of the user. Pause the screencast now and work on this challenge. To raise the state up, we'll simply take this line where we're initializing our state, and we'll move it into our app component. And then I will pass those props down. In this case, it's a very simple state of just the string Joe. So we will create a prop, maybe let's just call it user, and we'll set that equal to our user state variable here. Then in both the body and the header, we'll need to accept props, and we'll display props.user, and in the header, props.user. Clean up this challenge, hit refresh, and there we go. Now if I go to my app and I initialize my state differently, say Bob, and good, it updates in both places. Understanding that this is the way data flows in React can be really crucial in helping you architect your application in a way that you can share state amongst only the components that need it. And in fact, that's an important distinction to make at this point. it wouldn't be a great idea to initialize state way up near the top of your component if you don't have components along the entire tree that need it. Now, I'm not saying that every component needs to have access to that state for it to work, but if this component down here is the only one that needs state, there's no reason for me to put state in its parent or its grandparent and then pass stuff down through props. As a rule of thumb, keep state as local as you can, or in other words, keep it as closely tied to the component or components that need it as you possibly can. With this under our belts, I think it's about time for us to jump in and do a round of challenges to really exercise what you've learned up until this point, and we will start that in the next screencast. This is the beginning of a series of small challenges to really reinforce some of the past topics that we've been learning about. The first thing I want you to do is to take a look at boxes.js. You'll see I created an array of objects which have two properties, ID and on. And your first challenge is to initialize some state inside of our app component with the default value being this boxes array. And then I want you to map over that state array and display each one as just an empty square on the screen with a black border and a transparent background color. I don't think you necessarily have to set it as transparent. I think it'll just be transparent by default. For now, don't worry about using the on property at all, although you probably will want to use the ID property, and I'll let you figure out why. If you're using something like a div, don't forget to set a height and a width in the style on it. Ultimately, the goal is to make it so that if the box is set to on or on as true, then the box will be filled in with a color. And in the end, we'll make it so that clicking the box will flip its on value from true to false or false to true. But for now, let's just get some boxes displaying on the page, pause the screencast, and work on this first part of the challenge. We'll start by initializing some state. So I'll say, I don't know, maybe for now we'll just call them squares. And by convention, we'll say set squares. That's going to be from react.useState, and we'll pull in the boxes as the initial value. Then we need to map over the boxes. I'll save my array of elements. I'll maybe call it square elements. And that's going to be squares.map. For each square that we're looking at, I want to return a div. And notice here that I'm using parentheses instead of curly braces. That's simply allowing me to use the implicit return to return the element, and I'm just moving it onto its own line so it doesn't go too far to the left and right. We'll give this div a class name. Let's call it box. And actually, this is a class name, so it can just be the string box. I also know because I'm mapping that I'm going to run into that issue where I need to provide a key. In this case, I can use the ID property that's coming from each of these objects. Let's display our square elements and then we'll go into the style so that it will actually show up. Or rather, I should say, let's render our square elements. I don't think they are going to look like anything on the screen. Yeah, it's just empty. Over in our style, we'll set a style for box. And we'll give it a height. Maybe we'll do 100 pixels and a width of 100 pixels. We'll give it a border that's black. And then maybe just so we can see everything, I'll put these into a really simple grid just so that I can put them side by side a little better. Actually, I might not even bother with that. Let me give these a display of inline block. And I'll just put a little bit of margin right on them. Honestly, this is going to be good enough for right now. And awesome. Okay. The main things that I wanted you to take away were to practice setting state or initializing some state, and also practicing the .map method to create an array of elements that we can display on the page, as well as reminding you about this key property. If I take this out, I'm going to get that warning that React always gives if you use a .map to create elements but forget to add a key prop. So I will put that back in. Awesome work. On the next cast, let's do the next part of this challenge. Before we can do the next challenge, we need to learn about the style prop. You might be familiar with the concept that in HTML, I can add an attribute called style, and in here, I can insert CSS code. For example, I could give my div with the ID of root, or actually, you know what, let's do this on the body. I could add a style and say the background color is black. Hit refresh, and sure enough, my entire background color becomes black. Just like I can do this in HTML, I can do the exact same thing in React. However, because it's React and it's JavaScript, I can change the style dynamically depending on, for example, the value of our state or the value of incoming props on a component. Let me refresh this so we get our boxes back. And actually, I think I might just add a tiny bit of border radius to those boxes. Okay. To add dynamic style, I can add a style prop to my div. And in React, I'm not going to put a string the same way we did in HTML. Instead, I'm going to provide an object. Now, here's something that really confused me the first few times I saw it. This set of curly braces does not represent an object. It simply represents me entering into JavaScript outside of JSX. Or rather, it allows me to put JavaScript inside of my JSX, as we've learned before. Since I need to represent my style as an object, I'm going to put a second set of curly braces. This inner set of curly braces represents an object, a JavaScript object, and this first set of curly braces, or the outside set of curly braces, represents me going into JavaScript from JSX. Oftentimes, to avoid any confusion, what I'll do is I will not define that object directly inside of my markup, but instead I will create a separate variable, maybe called styles, and set that equal to an object. This makes it a lot more clear, and I can just put styles directly inside of my markup here. One thing to know about these styles is that they need to be camel cased. So if I'm changing the background color, I can't say background-color because this is not a valid key name in a JavaScript object. Not only that, but when I'm modifying the properties of a DOM element, you might remember that I could do something like document.getElementById, we'll say some kind of ID, and I can say .style, .background color with a camel cased property name and set that equal to something. Essentially, that's exactly what we're doing here. We are setting the style attribute of our DOM element to be an object, hence I can use the dot syntax here, and then I'm using the background color CSS property, but of course in the camel-cased version for JavaScript. Then because this is an object, I'm not going to use the equal sign, I'm going to use the colon to give my key a value, and I don't know, let's set it to black for now. Let me get rid of this equals so that, actually let me get rid of that whole line since I don't want to be doing manual DOM JavaScript here. Oh cool, look, I refreshed. My styles, which include a background color of black, are now being applied as the style of every square that I'm rendering, or every div that I'm rendering. So why is this beneficial over just using CSS? Well, because I'm using JavaScript, I don't necessarily have to have a hard-coded black value here. Let's suppose for a second that my app component is going to receive a prop that's called dark mode. In fact, let's go over to index.js and we will say that the app component is receiving a prop called dark mode, and let's set it to true for now. Over in my app, I'm accepting props here, and I will have a prop called props.darkMode. And let's say that if my props.darkMode is true, I want it to be black, and if it's false, I want it to be, I don't know, something light. Well, this is something I can use a ternary for, and maybe I should be more specific. This is something that you can use a ternary for. Using your knowledge of ternaries, make it so that if props.darkMode is true, it will set the background color to this hex value here, and if it's false, it will set it to this hex value here. One important thing to note is that these values need to be strings because we're in JavaScript, we're not in CSS. Pause now and work on this challenge. Let's take props.darkMode and we will put it here. And I'll say if that's true, then I'm going to use this string. And if it's false, I'm going to use this string. And it looks like I might have deleted my curly brace there. Okay, awesome. Now we can test this by simply changing my dark mode value from true to false. And awesome, look at that, it worked great. This can be a really fun one to play around with. If you'd like, you can pause and just play around with some of the other properties that we can change in the styles. Or you could try a little challenge of your own to see if the number of squares in this array is even, then make them all one color, or if it's odd, make them all another color. Really, your imagination is the limit here. When you're ready, we will move on to part 2 of our original challenge. It's time for part 2 of this challenge. I want you to move our div here into a separate component called box. And then when you're mapping over our squares, you will render that box component. That box component should receive a prop called on, and it will be the value of this square dot on. From our original boxes.js, each one of them has an on property, and that value is what you're going to pass to your new box component. Then inside of that box component, I want you to create a dynamic style like we did in the last screencast to determine the background color of the box. If the box is on, then you should set the background color to this hex value. And if it's off, you can just set it to the string none. Pause the screencast and work on this challenge. Let me create a new file called box.js. I'll set this up like normal. I know that this component will be receiving props, and I'm just going to copy this div and have that get returned. Now my key is going to be broken, and actually I'm going to pass this key into the box component. So let's go ahead and render our box component, which will be self-closing. This class name is already handled on the div that box is rendering. However, I will keep the key right here. The next part says to pass it a prop called on. So I'll say on equals, and then the value will be square.on. Again, each square here represents one of the objects in my array, and that has a property called on. Let's just make sure that everything is working so far. In my box component, I will console log props.on. And because I have 6 instances, I should get 6 values here. Oh, and of course, I did not import my box component, so I need to import box from box. Okay, let's try that again. Awesome. Okay, so I get my 6 values, true, false, true, true, false, false, and that's matching perfectly with what I see in my data here. Then the last part of this challenge is simply to make use of props.on to determine what the hex value or the background color should actually be. So using dynamic styles, I will create a variable called styles, and that's going to be an object where the background color is going to look at props.on, and if it's true, it will be this dark color, and if it's false, it will be none. Then I can simply add a style prop. Notice that my variable is called styles. You really can call this whatever you want. However, this attribute or this property needs to be style exactly that way. So I'll set that equal to the object that I created above. And I think I should see this one is dark. It was true, false, true, true, false, false. So this one should be dark, this one, and this one should be dark, and the rest should be clear. And that's exactly what we get. Next, we're approaching probably the most challenging part, and that is where clicking the box will actually flip the on value from true to false or false to true. I'll give you some hand-holding in that challenge, but honestly, it's going to be a pretty fun one, so that's what we will work on in the next lesson. In the next 2 challenges, we are actually going to be starting to dip our toes into some intermediate React topics here. The concept of changing state is what we have been practicing this whole time. However, we're going to see 2 different ways that we could structure this project and talk about which one is going to be the better of the 2. I put together a little diagram to make this a little simpler to understand. Right now we have an app component, and this app component is keeping track of an array of data. We're then using that array to create box components for every item in that array, and passing to those box components a prop called on, which will have the value either true or false. Currently, those box components are then taking this incoming prop and determining what the background color should be. However, at this point in time, they have no way to modify that incoming prop. Keep in mind that in reality, a component should never modify props. In other words, my box component should never say props.on equals something different. However, we do have some ways that we can still make changes to the background color of our box, and that's what we're going to be talking about. The first way we're going to see is to initialize new state in each one of these box components and set its initial value to the incoming props.on value. One benefit in doing it this way is the simplicity in allowing each box to then update its own state. Of course, by doing so, automatically every instance of our box component will also have the ability to update its own state. When I first started learning React, this was the most obvious way to allow each of these boxes the ability to flip its own value. And so that's what your challenge is this time. I want you to create some state inside of our box component. You'll determine its initial value based on the props.on value. You'll also create an event listener so that when the div of the box gets clicked, it can flip the value from true to false or false to true. While you're at it, don't forget to update your styles here in this ternary. Currently, it's looking at props.on. You'll want to make sure that you're looking at the local state instead of the incoming value of props.on. And the last thing is a quick change I made. In the previous screencast, I had set this to none, but it turns out this should actually be transparent if I want this to empty out the color. So don't let that be confusing. Okay, this is your time. Pause the screencast and work on this challenge. In truth, this is very similar to what we have already done so far. I'll initialize some new state. We'll call it on, and it will also receive our setter function, which I'll call setOn, by calling react.useState. The initial value should be determined by looking at props.on. I'm going to update this to not look at props.on anymore, but to look at my new state value of on. And that way, when I make a function, let's call it toggle, and it calls setOn looking at the previous version of on and simply giving me the opposite of whatever that previous version of on was, I can then set this up as a click event listener to run toggle. Should be able to clean this challenge up, hit refresh, and sure enough, I'm able to flip the value. Now it's not readily apparent, but keep in mind that what we've done is we've given each one of these boxes its own value of state. So basically, we've given it the ability to control itself. We've given it the control over its on value. Now, I understand the boxes seems a little bit contrived. However, this same concept would apply to something like a to-do list, for example. Our app would be like the to-do list, and each of these boxes would be like a to-do item. The value of on might be replaced with a value called maybe completed as to whether or not that to-do item has been completed. Structuring it the way that we just did here, every item in our to-do list would be in charge of knowing if it by itself has already been completed or not. When I first started writing React, this seemed like the most obvious thing to do. However, I've since learned that there actually is a better way to structure our application so that state is only held in the app component in our example here. There certainly might be situations where creating state in each one of the child components and initializing that state based on the incoming props might make sense. However, general consensus is that if you find yourself initializing state by using the incoming value of some prop, there's probably a better way to do this. And that's what we'll be diving into in the next lesson. Previously, what we did is we created new state inside each of our box components and initialized that state based on the incoming prop of on. And it turns out there's actually a name for when you create state that is initialized by incoming props. And it's called derived state. And I'm sorry to break this to you, but it turns out that you probably don't need derived state. This is an article that was written in 2018. You can click on the link. It's in the React documentation. It will probably get a little bit heavy if you're still a beginner in React, but it turns out that there can be some weirdness that happens if you pass a prop to a component and then just take that prop and set state based on that prop. If you think about it, in app.js, we actually created some state in app.js to maintain all of the squares already. So when we set state in each one of our boxes, we had state both in the app and in every one of our boxes, which in the end means that there are two sources of truth. When the box had the ability to update its own state, it was not updating the state on the app component. It was only updating its local state that it had derived based on the incoming props. And because of that, there were multiple sources of truth. Now, certainly there are circumstances where derived state makes sense. This article does talk about some examples of that. However, it's far less common than I think most people end up using when they're writing React applications. And the whole reason I decided to talk about this in this course is to help you navigate a scenario that, at least for me, was really tricky when I was learning. So we're going to approach this in a different way. Instead of putting state and a setter inside of each one of our boxes, we're going to make use of the state that already exists in our app. And instead, we're going to create a function called toggle inside of our app component, and then pass that toggle function down to each one of our box instances. Anytime one of the box components gets clicked, it will run this toggle function and essentially tell the app component, hey, the state that you're maintaining needs to change. Then when that state changes, let's say this first object gets clicked and it changes from true to false, React will re-render the app component because its state has changed, and therefore will re-render the box components, but now with the first one having an on value of false. You certainly are going to notice that this way of doing things is more complex. However, in the end, it is a better practice than using derived state to manage our state. Because of the additional complexity, I'm going to give you a challenge that has you doing part of this, and then we're going to walk through completing it together. So let's go ahead and get started. The challenge is for you to create that toggle function that for now is just going to log clicked to the console. Then I want you to pass that function down to each of the box components and set it up so that when they get clicked, it simply runs the function, which means it will console log clicked. I've already removed the state from our box component, so that isn't something you have to worry about. Pause the screencast and work on this challenge. Okay, let's create a function called toggle. Simply enough, it's going to console log clicked. Then we're going to pass that function to each one of our boxes. We can choose the prop name we want. Sometimes I'll use what looks like the onClick event handler, but keep in mind that because this is a custom component, it won't automatically register this as an event listener. I think more often I'll choose something like handle click that makes it very clear that I'm talking about handling an event. However, I also could just give it the name of the function. Really, we can do whatever we want here. Let's stick with toggle for now, and we'll pass down the toggle function. And now inside of box.js, I'm receiving a prop called toggle, and this is where it does need to be on click with the capital C. We'll use props.toggle. I'll hit save, and clicking it, awesome, runs the function that we defined. This is the point where some additional complexity needs to be added in order for this to work correctly. When each box was initializing its own state, it was really simple to know which box was flipping its value because, well, each box was maintaining its own state. However, now with our toggle function, the toggle function has no idea which box just ran its code. So in my app component, if I wanted to use set squares, because squares is an array, I need to figure out which of the items in the array triggered set squares so that I can update the correct one and leave all the other ones exactly how they were. And this is where we are essentially forced to do something a bit clever. And I figured at this point it would be better for me to walk you through some examples of how we might solve this problem. Let me clean up our challenge. Our goal is to give the toggle function the ability to know which box was clicked so that we can correctly update the state array. One way we could do that is to make it so that the toggle function takes the ID of the box as a parameter. However, as it's currently set up, this is not going to work. And that's because in our onClick here, we really don't get to decide what parameter gets passed to our function. Every browser will pass an event handler function, the event itself. It's an event object that describes a bunch of information about the event. In fact, I can see that really quick. Here I will, instead of console logging clicked, let's console log ID. which we're going to be disappointed in what actually happens. I'll hit save, click a box, and you'll see I get a synthetic base event, clearly not the ID of the box that was clicked. However, we can work around this by, instead of just blindly running props.toggle, we can run our own function, which then runs props.toggle. This is the function that is going to receive the event. However, we're not going to make use of that, so I'll just delete event. And then this function can run props.toggle, and now we have the ability to pass whatever we want here. In this case, what we should pass is the ID of this box. However, currently we're not receiving that ID. Sure, I have this key prop. However, the key prop really is intended for something completely different, and I'm fairly certain that if I even tried to access that key prop, let's console log props.key, yeah, I'm going to get a bunch of undefineds. I don't have access to props.key inside of this component. But that doesn't stop me from passing another prop, let's call it ID, and it essentially is the exact same thing. Now I do have access inside of box to props.id. So if I console log props.id, I get the IDs of each of the boxes. And now I can use props.id to pass that information, pass the ID to my toggle function. Now over in app.js, if I console log the ID that's coming in, of course this will only run when I click it. Let me click the very first box, and that is my ID of 1. This one should be 2, 3, 4, 5, and 6. Awesome. This is great news because now I can use that ID to update the correct square in my setSquares function. At this point, I think this is something that you'll be able to do as a challenge. This lesson's getting a bit long, so that's what we'll do in the next lesson. I'll admit right now, this challenge is going to be a little bit tricky. Your goal is to use our setSquares function to update the correct square in the array. Remember, we're receiving the ID and we just want to flip its on value from true to false or false to true. However, the trick is to not change state directly. As a hint, you could go back to the lesson on how we updated arrays in state if you need a reminder on how to do this. However, in that lesson, we mostly just touched on adding new items to that array. In this case, we're not adding new items, we are updating one of the existing items. At this point, it might be tempting to use an array method like splice. However, that is going to directly modify your state because splice alters the array that it's run on. So don't let any of that scare you. I really want you to try your very best to do this. If after maybe 20 minutes you're still struggling on figuring this out, you can always just hit play and we will walk through this together. So let's have at it. Pause the screencast and work on this challenge. Okay, we'll use our setSquares function. As usual, we do need access to our old version of squares in order to determine the new value of our squares. So I'm going to say previous squares. And instead of getting really clever and figuring out a way to do this on a single line, I'm just going to open up this function so we have some breathing room to create variables and do whatever we need. In fact, let me solve this in maybe the least clever way I can think of. I'm going to create a new array. We'll say new squares. I'll set that equal to an empty array, and I'll do a very simple C-style for loop. We'll say let I equal 0, I is less than previous squares.length, I++. And my goal here is to look at each square in the array of squares, and if its ID is equal to the ID that our toggle function got, then we will simply flip the on value to the opposite of whatever it currently is. If we are looking at a square that is not the one with this ID, then we'll simply push that to our new squares array. So let's say our current square is the array of previous squares at the index of I. And now I'll say if our current square that we're looking at has an ID that's equal to the ID given to our function, then I'll say maybe updated square is equal to an object that has all the properties of my current square, except the on property is going to be the opposite of my current square.on. And then I have this new object, and I will push that to my new squares array. So I'll say new squares.push updated square. However, if the ID is not the same, so I'll say else, we're just going to simply push the current square to our new squares array. At the end of this for loop, we should end up with an array that looks almost identical to the original array, prev squares. However, one of the items should have a flipped value for its on property. And so we can see this is getting a little bit long, but there's my for loop. At the end, we'll simply return, because that's what we need to do from our set squares function, is return the new value of state. We'll return our new squares array. To be totally honest, I haven't tested this out. Let's hit refresh, see if this works. Oh, look at that. Awesome. Let's walk through exactly what this is doing. Let me clean up my challenge to buy us some room here. Every time I click on one of these squares, it's running the click event handler that we defined here. That click event handler is running the toggle function that it received through props and passing in the ID that it also received through props. That toggle function is taking that ID, running set squares, and running this function to determine what the new square should be. We look at the previous array of squares and simply generate a new array, loop over the previous array, and when we run into the square in our loop where the ID matches the ID passed into toggle, we create a new object that will replace the old object and push that to our array. If the IDs do not match, we just push the current square in its current form without any changes made to our new array, and we return that. By returning this new array, React will update our squares state array, which means that it will then re-render this component, remap over all of our squares, and create 6 new box components, pass the on value, which was the same in 5 of the squares but different in one of them, and then in our box component, it will simply take that prop and determine what the background color should be. All of that seems really complex. I totally understand that, but you can see it's quick and there really is no lag in doing this at all. At this point, we could just move on from this. Let's say it's a feature we're adding to some app we're creating. However, as we've learned, React really adheres to the principle of writing declarative code. What we have here is very imperative. Doing a C-style for loop this way works perfectly without any problem. So if you're happy with this, you can just move on. But I think it might be worth our time to take a look at how we might write this slightly differently using something a little more declarative instead of imperative. So that's what we'll do in the next lesson. I'm not going to bother making this a challenge this time. I think I'll just walk you through how I oftentimes will update an item in an array using a more declarative method instead of using a C-style for loop like we have here. So let me go ahead and just delete everything inside. And I think what I'll do is use the .map method to help me create a new array and return that array all in one go. So I can say return the previous squares .map, and whatever I put into my map function here is going to help determine my new version of the array, which then gets returned from my .map and returned from set squares. This is a lot of returns happening all in one, but let's just see how I would do this. I need to look at each square inside of my map, and whatever I return from this callback function inside of my .map is what will get placed at the same index in my original array in the new array that I return. So what if I were to use a ternary that said, does square.id match the ID passed into my toggle function? If so, I want you to return a new object that has all of the properties of square except for the on property, which is the opposite of square.on. However, if the ID does not match, that's my else here, then I can simply return the square. The only thing I'm missing now is the return keyword. I tried to leave it out in the beginning because these two returns can be a little confusing at first. So fingers crossed, let's hit save, and look at that, everything is updating beautifully. Obviously what we have here is a lot more concise in terms of lines of code, but it does require a bit more of an advanced understanding of JavaScript to fully comprehend. In my experience, what I have here is not so clever that other software engineers would not understand it, and therefore I personally would prefer a solution that looks more like this. I would definitely spend some additional time understanding this if this is confusing, but I will walk us through it one more time. Every time box gets clicked, it runs this function, not just props.toggle, but this function that we've defined inline here. That function will run props.toggle. Remember, we did that so we could pass a parameter, a custom parameter, to props.toggle, which we decided to be the ID of the box itself. Then if we go over to the toggle function, it will call setSquares, our state setter function, and we need to use the callback function version of setSquares because we do care what the previous array looked like. So we look at the previous squares and we're going to map over those squares. As a reminder, .map returns a new array without modifying the original array that will have the same length as the original array, and whatever we return from the callback function of .map is what will get placed in the same index in the new array as what was in the original array. What we're doing every time we loop over an item in this array is we're checking if its ID matches the ID. This ID here is the ID that we passed into our toggle function. If those IDs match, then that means it is the square that was clicked. If that's true, then I want to replace the old object with a brand new object, which is why I have these curly braces here. And this is crucial so that I'm not updating state directly. This object is going to pull in all of the values of square exactly as it was, but then it's going to overwrite the on value with its opposite. However, if this is not the box that was clicked, then just give me the old square. In this case, because I'm not making any modifications to it, I don't need to create a new object and spread in the old square or anything like that. I can just hand the old square object directly to my new array. Awesome work. I really hope you were able to follow along with that logic. This truly is something that just takes a lot of practice. At this point, one of the very best things you could do is just delete our toggle function completely and try to recreate it from scratch. In the end, this toggle function is the most complex part of what we have here, so that would be a great place to start if you really want to challenge yourself. I did want to show you one other rather clever solution that we could use instead of passing an ID down to the box, and that is that we could just say our toggle function that we're passing down, just like we did inside of our box, is going to be an individualized toggle function, this entire function here. However, we can pass the square.id immediately as we're passing this toggle function down. In essence, this creates something called a closure, where each instance of our box will have its own toggle and it will remember its own ID, which means I can get rid of this ID prop, and over in box, I can change this back to just toggle, or rather props.toggle. If I hit refresh, we can see that it's working exactly like it was before. Again, awesome work. I really hope that as you have followed me in this mini series on setting state and creating this rather silly little app, that you have worked on the challenges that I've given you. If you haven't, it's not too late. Don't just push forward. Go back and work on these challenges. Make sure that you really understand everything that we've done so far. Pushing forward without understanding this is not going to help you. It's only going to make it harder going forward. Spend the time now to really clarify these things. Ask questions in the Scrimba Discord, and then when you really understand it, you can be happy knowing that you are ready to move forward. Okay, well, this might look familiar. This is our joke component from the previous section, and we're going to use this to kick off a sort of mini-series on learning about conditional rendering in React. Using and understanding conditional rendering is very important in React because you will see it everywhere in React code. To start us off, I have a challenge for you. You're going to create some state called isShown. Its value will be a Boolean, and you'll just default it to false. The idea is for it to be a piece of state that will decide whether or not the punchline should be shown in each of these jokes. And then I want you to add a button, probably just right here below the paragraph, that will toggle that isShown value back and forth. Pause the screencast and work on this challenge. At the top of my component, I'll have my state called isShown and set isShown. That'll equal react.useState. The default value will be false. And then we'll add a button Let's have this say show punchline. Then let's create a function that will help us toggle our value back and forth. We'll just call it toggle shown. And all it's going to do is run set is shown. We do need to know what the previous value of is shown was, so I'll say prev shown, and that way we can return the opposite of prev shown. That'll just flip it from true to false or false to true. And let's add our onClick event listener here to run toggle shown. While we're at it, I'll go ahead and console log the current value of is shown. And when I click show punchline, okay, now you'll notice that it said false, even though I'm flipping it. That's because it first console logged is shown, which initialized as false, and then I called set is shown. If I click it again, I'll see the old value right before it got changed. This console log's not terribly important anyway, so we'll take it out. One of the reasons I use this joke component to help us learn conditional rendering is, well, I used it already as a way to give you a sneak peek into conditional rendering. Since we have a template here already, even though this might seem a little backwards, I want you to make it so that our paragraph here only shows up if is shown is true. Again, you have a template to help you understand how that works, and then once you have that working, we'll talk through the logic and really fully understand exactly what's going on. Let me update our challenge text here. Okay, make it so that this paragraph only displays if the is shown boolean is true. Pause the screencast and work on this challenge. Well, as we see here, what we did is we surrounded everything in curly braces, and that allows us to put a JavaScript expression in here. In our case, we're going to say if is shown is true and this paragraph. First, let's see if this is working. Okay, all of our paragraphs, our punchlines are gone. And if I click show punchline, awesome, our paragraph displays. Now, why on earth does this work? When you first learn JavaScript, we usually learn about how this AND logical operator, the double ampersand, is used to make sure that both sides are true or truthy. So let's say you have a couple variables. We'll say condition 1, we'll call it true, and condition 2, let's say that's also true. And if you have an if statement that says if condition 1 and condition 2, meaning if both of those are true or truthy, then the code inside this code will run. We also learned that if either one of these are falsy or false, so if I change either one to false, this code will not run. However, if we look deeper into how the computer is actually running this code, it can be very enlightening. For example, let me change condition 2 to a console log statement. This is kind of a strange thing. You're not really going to see this in the real world, but it's just to prove a point. We'll say, hello there. Let me open the console, and I'm going to click save, and we'll see that we immediately get the console log running of hello there. Now, let's see what happens if I change condition 1 to false. I'll hit save, and nothing gets console logged. That's because what the computer does is it first checks the truthiness of this first statement, and if it is not truthy, if it's false or falsy, it actually completely skips whatever it sees after the double ampersands. Since it already knows that this condition will not satisfy what the AND is expecting, in other words, for both sides to be truthy, it knows already that it can completely skip whatever it sees here. So we can take advantage of this in React anytime we have an element on the screen that we want to display if something is true, or completely hide or not even render to the page if that thing is false. Here with the setup, we realized that some jokes were just one-liners. They didn't have a setup and a punchline, they just were the punchline. And in that case, we looked at our incoming props.setup and said, if that's falsy, then don't display this h3 at all. Similarly, with our local state of is shown, we can say, I only want to display or render this paragraph if is shown is true. By doing that, we can have a toggle button that when it's clicked will change is shown of this individual joke component to true, and therefore it will display our paragraph. More specifically, when I click this button, React will re-render this component because its state has changed, and therefore when it's running the return value again and determining what should actually be placed on the screen, isShown is now true, and therefore this expression gets run and put onto the page for us. So as a recap, in React, when you have an element that you either want to display or not display at all, using the AND logical operator is a really concise and great way to do that. This challenge is a pretty straightforward one. Based on what you just learned using the AND logical operator, make it so that this h1 will only display if our array of messages is not empty. If this array is empty, then this h1 should not display at all, and we should end up with a blank page. While you're at it, go ahead and fix our little underline for the number of unread messages we have in our array. Pause the screencast and work on this challenge. Well, first let's replace this underline. We can put in a set of curly braces and simply say messages.length. Okay, that's a good start. Now, if we're deciding whether we want to display this at all or not, then we can use the logical AND operator to say messages.length is greater than 0 and display this h1. That way, if messages.length is greater than 0 is a false statement, in other words, if messages.length is equal to 0, then this h1 will simply not render at all. A more concise way might be to just say messages.length and this h1, and that's because the number 0 is considered a falsy statement. However, I think it reads a little better to be explicit and say the greater than 0 there. Sometimes if this line gets a little bit long, you can break it out onto its own line, something like this. And we can test this by emptying our initial state array. And there we go, we have nothing on the screen. Awesome work. Next, we're going to see another method for doing conditional rendering in React. We have a funny UI bug right now. When we click Show Punchline, it shows the punchline, but the button still says Show Punchline. Knowing what you know so far using the AND operator to conditionally render something, I want you to think for a second, how might you change it so that it says Hide Punchline instead of Show Punchline when the punchline is shown? One thing we could do is make a copy of this button and display them at different times. So I'll do my similar conditional rendering and say if isShown is true, then I want this to say hide punchline. And if isShown is false, or if not isShown, then I want this to say show punchline. Technically, this will work. So it says show punchline, and then it changes to hide punchline. However, we can do better than this, and we can do so by using the ternary operator. The ternary is really helpful when you want to display one thing based on a condition or another thing if that condition is falsy. So instead of duplicating our button, I can keep my button here and simply change the word from show to hide using a ternary. Let me show you what that looks like. I'm going to delete the word show, put in a set of curly braces because I want to use JavaScript now, and we're going to use a ternary looking at the Boolean value isShown, and I'll say isShown question mark. Now if isShown is true, then I want the string hide to be displayed at this point in the button. Otherwise, I want it to say show. I hit save, it's showing show punchline, and when I click it, it changes it to hide punchline. As far as conditional rendering goes, probably 95% of the time you will see conditional rendering handled with either the double ampersand or a ternary. Again, the double ampersand is great if you either want something to display or not display, and the ternary is great if you want to choose between one of two things to display. If your conditions are more complex than just having one of two options to display, usually it'll be best just to turn to a regular old if statement as we have seen in the past. You can save a variable for your text and do either a switch statement or a series of if, else statements to determine what that variable should be and then just display it in your return down here below. Since we've already seen what that looks like in the past, I'm not going to cover it now. I mostly just wanted to look at these two methods for conditionally rendering something in React. Now that we've learned that, let's get a quick practice in. Let's do some conditional rendering practice. One thing I've done with our messages app is I changed this to just say messages instead of num messages because, well, that just makes more sense because this is an array of messages, not a number of messages. Anyway, your challenge is to display the correct thing on the page. If there are no unread messages, it should display "you're all caught up." And if there are any messages in the array, it should display "you have n unread messages," where n represents the length of the array or the number of messages in that array. As a caveat though, notice I put this parenthesis s here. That's not literally the text parenthesis s. Instead, I want you to, if there is exactly one unread message, put the word message there instead of messages. So pause the screencast and work on this challenge. There certainly is more than one way to accomplish this. For example, I could always render an h1 and then use a ternary inside for the text of that h1. For some reason, that doesn't sit quite right with me. I'm honestly not sure why, but I think the way that I would choose to do this is just to open my curly braces, look at the messages.length, and say if that is exactly equal to 0, and here I'm going to use a ternary, so I'll start a question mark. On the next line, this will be what should display in case there is exactly 0 messages. So I'll do an h1 here and say "you're all caught up." Otherwise, I'll put a different h1 that says "you have," and let me just put the number hard-coded here for a second, "unread messages." Okay, I'll replace this 2 with messages.length. And well, let's see where we are right now. I'll hit save. You have 2 unread messages. If I remove the items from the array, you're all caught up. Awesome. At this point, it might be tempting to do some kind of nested ternary here that says if messages.length is exactly equal to 1 and put another ternary as the else of this first ternary. Personally, I think this is nearly impossible to reason about, and so I never do nested ternaries myself. I suppose one thing I could do is just render this s if messages.length is greater than 1. I think that would look something like this. I would put message and then a set of curly braces and put in my JavaScript here that says messages.length is greater than 1 and the string s. Let's just see if that works. Personally, I don't love this solution. I'll add in a couple items here. Okay, we have 2 unread messages, and if there's only 1 item, okay, you have 1 unread message. However, when I look at this, it's not quite as clear as what I think I would prefer to do, and that is to type out the whole word message or messages and use a ternary. Let me show you what that would look like. You have blank, unread, and then I will open up some JavaScript here and say, is messages.length greater than 1? If so, I want it to say messages, but otherwise I just want it to say message. I'm going to put this onto its own line just so we have some extra space. And although this does take up more characters, I think, than what I had before, to me this is a lot easier if I have a fellow developer who's going to be coming onto this project and needs to understand what I'm doing here. I think this is easier to reason about and understand. As you can see, there are multiple ways to use conditional rendering, and this is the kind of thing that I'm talking about when we say that React is just JavaScript. Just like in JavaScript where there's multiple ways to solve a single problem, it's the exact same in React. Because you're just using JavaScript, like ternaries and the logical AND operator and so forth, you truly could solve this in probably dozens of different ways. Most people will tell you to find a way that is easy to think about in the future, and then to stay consistent throughout your entire code base. Let's go ahead and test this before we call it a good solution. And yeah, see, I need a space there, so we'll put an extra space in there. Oh, and I guess breaking this onto its own line might not have worked. So let's just leave it like that. Okay, 1 unread message and 2 unread messages. Awesome work. When you're ready, let's keep moving forward. It's that time again for another quiz. Pause the screencast, click into the editor, type your answers down, and when you are satisfied with your answers, click play and we'll go through the quiz together. Number 1, what is conditional rendering? Conditional rendering is just a way to determine whether or not something should get displayed, or, as we're going to see, what among many choices should get displayed. Unlike a regular HTML page, which will always display whatever you hard-coded into the HTML, with React, we can use conditional rendering to sometimes not display that thing, or to sometimes display one thing instead of another. So conditional rendering is when we want to only sometimes display something on the page, usually based on some sort of condition. Or maybe I should say always based on some sort of condition. So far we've learned a few different ways to handle conditional rendering. When would you want to use the double ampersand or the AND operator? The AND operator is great to use if you want to decide whether or not to display something at all. So in other words, when you would want to either display something or just not display it at all. In that case, what you put before the AND operator is the condition, and if that condition is true or truthy, then the JSX element that you put on the right side of the AND operator is what will either get displayed or not get displayed based on the condition of the thing on the left of the AND operator. Number 3, when would you choose to use a ternary? Where the AND operator is great for deciding to display or not to display something, a ternary is great for deciding which among two things you want to display. Technically speaking, you can nest ternary operations inside of other ternary operations, but personally, I highly recommend not doing that. If you find yourself needing to choose between more than two options, you probably should just be using regular conditionals with if, else if, and else, or possibly a switch statement. And, well, I guess I just answered number 4. So if you do need to decide between more than two options, you should use a regular conditional statement using if, else if, and else, or a switch statement. There's one slight difference between the and ternary and what you can use with an if, else if, else block, and that is that the and the ternary can happen directly in line inside of the returned elements of your function, whereas with the if or else if or the switch statement, those will have to happen outside of the return of your function. So if I have a functional component, let's say it's app, and I'm returning some kind of UI, the and the ternaries can happen right here in line. So I can have something and some JSX. Or I could use a ternary that has the condition and the ternary, and then an else inside the ternary, which is some other element. But if I need to use an if, else if, and else, or a switch statement, I can't do my if inside of the JSX directly like this. Instead, I need to go up above. I can set a variable, and then use my if, and else if, and else block to set some variable to some kind of JSX. I won't type out the whole thing, but that allows me to then just inside of here display some variable, because previously in my if statement it was determined which JSX element it should be. Great work on this quiz. We still have a lot left to learn in this section, so let's keep moving forward. We're going to spend a fair amount of time talking about how to manage and deal with forms in React. From the outside, this might seem like a kind of strange segue for us to be taking. However, I have found that forms are one of the most difficult things to understand, and truthfully, one of the most difficult things to use in React. If someone were to ask me what I think is one of React's greatest weaknesses, I would probably say forms. Fortunately, there is a plethora of really awesome form libraries out there that, in my experience, many people end up turning to in order to manage forms and not have to build everything that we're about to see and learn about from scratch. However, that being said, it is really important to know how to do this because, especially when you're dealing with a really small form like what we're about to see in the meme generator, it's not that difficult, and once you get enough practice under your belt, it's pretty straightforward. So why are we talking about forms in the first place? Well, in the old days, you would create a form in your HTML and you would give it an action, which had the URL usually of some kind of PHP file that would process your form. You would give it a method, usually of posts, and then when your form was submitted through some sort of submit button, your PHP would pick everything up from there and process the data from the form. Fast forward a little bit to slightly more advanced JavaScript, but still vanilla JavaScript, and you would likely see something that looked kind of like this. This selector goes and gets the form, it adds a submit event listener, and the function that runs whenever the form is submitted would simply gather all the values together and then submit it to an API somehow. Of course, my function is just console logging stuff. If I were to type in a first name and last name here, let's put Joe Schmo, and it's just console logging our data. The main takeaway here, though, is to know that when you're submitting the form, it would gather all the data immediately at the very end of the process and then submit it immediately after gathering it. So how is this different from React? The main difference in React is that instead of waiting until the very end of the process and filling out the form when the form is submitted and then gathering the data, instead what we do is we create state, and every keystroke change or checkbox change or radio button change or whatever it might be, we update state, and therefore we are watching these inputs every keystroke or every change that's made to our form. Then when the time to submit comes, there's no more work really to be done. We already have gathered the data and we simply submit that to our API and pass in the state that we have been tracking all along. Coming up, we are going to jump into the specific syntax of how to do this. However, I really think it would be a good idea to sort of pre-game for these lessons by reading through the React documentation on forms. I know forms can seem like a rather mundane topic, but I promise this documentation from React is really excellent. They've done a great job explaining it. Think of this like reading the textbook before coming to class. Once you've had a chance to at least skim through the documentation and gain some level of understanding on forms in React, you'll be ready to move on to these next lessons where we start learning about how to deal with forms in React. Let's see how we can manage these forms in React, and we're going to start very simple with a single input. I'm keeping this as simple as possible so not to distract us from anything but learning forms. As a reminder, in vanilla JavaScript, we would have a submit button, and when we click that submit button, it would run a function, gather all the data at that time, and then submit it to an API or wherever. What we'll be doing in React instead is maintaining up-to-date state for every change that happens in any input in our form. To accomplish this, there's a few things we need to do. First of all, we need some state to hold the current data that's typed into our input. Just like we've been learning, I can say, let's say first name and set first name is equal to react.useState. I will set an empty string as the default because I would expect my input to be an empty input box in the beginning. And now what I need to do is listen for any changes that happen to this input. Can you think what event listener I might need to add to my input to accomplish this? Most or all form elements have an event called onChange, and I can set that equal to a function, let's call it handleChange, which I obviously haven't declared yet. So let's declare that function, and for now let's just console log changed. I hit refresh, and now we can see every keystroke that I make is running our function. Now, one thing we haven't spent much time talking about is this parameter that I can actually receive as a part of my event listener function. In this case, I don't get to decide what actually gets passed to my handleChange event listener function. Instead, what will get passed to it by the browser is an event object. This event object is really large. It has a lot of information in it. And if I console log event in Scrimba, it's simply going to put synthetic base event. So at this point, I'd recommend you actually open your developer tools in the browser and see exactly what got logged to the console. You'll be able to dig into all of the properties of this event object. However, there's one property in this event object that I care the most about, and that is one called target. If I log event.target, we'll see that it gives me what Scrimba shows is the HTML element that triggered this event. Now it looks like HTML in the console down here, but in reality, it's just the DOM object that triggered this event. That DOM object has properties that we care a lot about. For example, the value property. Let me hit refresh and I'll just start typing letters, and you can see in the console, we're logging the current value on every keystroke of that specific input box. So let me set up a quick challenge for you. Your challenge is to update the first name state on every keystroke. I've set everything else up for you. You should be able to complete this challenge fairly quickly. I've added this console log here. What this will do is every time the first name state changes, it will re-render your component, and therefore it will rerun this console log. This is a really simple way for you to see that everything is working. Assuming you hook everything up correctly in our handle change function, this console log line should fire every time you type into the input box. Pause now and work on this challenge. Simply enough, we should be able to use the set first name state setter. And in this case, I don't really care what the state used to be, or rather, I don't need to know what the state used to be in order to determine what the state is about to be, because I have quick and easy access to the information that's currently typed into the input box by accessing event.target.value. So I should be able to get rid of these lines. I'll hit refresh, and I'll start typing in my input box, and sure enough, our state is updating with every keystroke. And there we have it. As you can see, at least starting out, this isn't that terribly complicated. However, I am about to throw some wrenches in here. We're going to see that the complexity level will rise a little bit. However, before I do that, I want to get your hands on the keyboard, and we'll do that as part of a challenge. In this challenge, we want to add a last name input to our form. As I've done before, I'm being a bit intentionally vague here, and that's so that I can get you to think of all the steps that you would need to run through in order to get this to work. So do your very best in this challenge, and when you feel like you've got a good solution, you can hit play and I will show you how I would do it. Pause now and work on the challenge. As you worked on this challenge, you might have started to see places where we were not being dry in our code. In other words, we were repeating ourselves quite a bit. For example, I could duplicate this line, and I will change first name to last name. We'll say set last name. I then could duplicate my input, and we'll change this to last name. Now, of course, there's a problem with using the handle change function on change, and that is because, well, handle change is only changing the first name. So maybe we make a change that says handle first name change. We'll update our on change there, and then we'll duplicate this function and handle last name change. You can probably see where I'm going with this and how this is not going to be the ideal solution. And then last of all, we need to change this to set last name. I'll add a console log here just so we can see if things are working the way we expect. We'll look at both the first name and last name. We'll hit save, start typing. We're looking at Joe, Schmo. Okay. Of course, this seems to be working, but we can clearly see this is not ideal, especially when you think of some of maybe the crazy forms that you filled out before that have, let's say, 20 or maybe even upwards of 50 input boxes. It's not going to work great for me to have a separate change function for each one of those and a separate piece of state for each one of those. So next what we'll do is we'll learn how to combine our state into an object and how to use the event parameter that we're receiving in our event handlers to determine which property of that state object we should be updating. So when you feel confident with everything that we've worked on here, let's jump into that next. Let's see how we can improve our form and how we're managing state so that when the time comes to add, let's say 20 or 30 more inputs, we don't end up drowning in duplicated code. Now, if you do just have 2 or 3, maybe even 4 pieces of data in your form that you care about, doing something like this might be okay, or at least manageable. Once you get to 4 or beyond, however, it starts to make a lot more sense to save your state in an object instead of in separate variables. A benefit of doing that is we'll receive one setter function, which we're going to learn how to use to update the correct piece of state in the object. Let's just dive into the syntax to make more sense of this. I'm going to remove this extra function here. Let's change this back to handle change so we can figure out a way to make it more universal, and I'll set my onChange to work for both of those. Let's also get rid of our extra piece of state here, and instead we're going to choose to save an object as our default, and that object will have a first name property as an empty string and a last name property as an empty string. Let's move this onto its own line. Then I'll change first name to something more generic like form data and set form data. Lastly, let's get rid of this so that we don't have broken code. And awesome, this is a good starting place. If you remember back when we talked about the event that we're receiving in our handle change event listener function, if you did spend some time in your developer tools poking around that object and looking at its properties, you probably saw event.target, which we talked about in that previous lesson. Now in Scrimba, if I console log this event.target, it gets a bit truncated to look like an HTML element. However, under the hood, it's really a DOM object that we can access properties on. In fact, we saw how I can look at the value property to get the specific value that was typed into the input box. However, at this point, because an object is what we're saving in state, I can't simply say set form data to event.target.value because that would erase my object and replace it with just a simple string. And because I'm using the same handle change function on both of my inputs, I need a way for the handle change event to distinguish between which input it was that triggered that event. Well, it turns out that a good practice that we're neglecting to do right now is to give each of our inputs a name property. This is true of regular HTML forms in any case, but in React, it's going to play a special role for us. What I can do is make the name property match exactly the property name in the state that we're saving. In fact, a good idea is to just copy and paste it so that you don't misspell it. And now I have access to event.target.name. Let's hit save. I'll trigger the event to happen in the first name property, and you can see it logged the first name property there. If I do it in the last name, it logs last name. Well, this is a great start. We have access to the property of state that we want to change, and we still have access to event.target.value, which is the value that we want to change it to. So now we have everything we need to call set form data and update our object correctly. Let's go ahead and call set form data. Before, when we were simply updating a string, we didn't care about what the previous version of that string was because we were just going to overwrite it with whatever was in the input box. This time around, however, we do need to know what the old version of state was because we have a lot of other properties. Well, in this case, we only have one other property, but imagining a larger form, we have many other properties that we need to maintain instead of just overwrite. So I'll do a callback function in here. I'll use an arrow function and call my previous state, let's say prev form data. I'll use an arrow function and open up the body of that function. My goal is to return a new object, and I want to make sure I keep all of the old object intact. So I'm going to spread out the previous form data, but then I'm going to overwrite the specific property that we are trying to overwrite or that we're trying to update in this handle change event listener. Well, on your first attempt, the inclination might be to try something like, let's use event.target.name as the key and event.target.value as the value. Of course, as we can see in the editor, this is a syntax error. However, with ES6, there was a feature introduced called computed properties. And what this allows me to do is to surround my key here in square brackets. Long story short, it makes it so I can turn a dynamic string like something saved in a variable and use it as the property name for my object. If that doesn't make a whole lot of sense, don't worry too much. Just know that you can fix the syntax problem by having dots here by surrounding it in square brackets. That's an overly simplified way to describe it, but don't worry too much about that. That's not the important part to take away from this lesson. Let me add back my console log so we can look at our state every time it changes. I'll hit save. We can see in the console that it's empty to start with, and as I change the first name, my object is updating correctly. My last name is also still a part of my state. As I update the last name, awesome. This is great news that my entire state is staying intact. Honestly, what we just learned in this lesson might be one of the most difficult parts of understanding forms in React. So for those of you that were able to follow along, awesome, good job. For those that were struggling still, that's completely okay and completely normal. Don't be afraid to go back, rewatch this a few times, and because of that, in the next screencast, we're going to practice this a little bit more. Hopefully in this challenge, you'll get a chance to see why it's beneficial to structure things the way that we just learned how to do. Your challenge is to add an email field and associated state to our form. Pause the screencast and work on this challenge. Previously, when we were saving all of our state as strings, anytime we wanted to add new state, we needed to create new variables and new event handler functions. Now, however, we simply need to add a field to our state object here. We'll add an email property that starts as an empty string. And as long as with my input I give it the correct name, I really don't need to change anything about my handle change function. So let me add another input here. I'll just duplicate this one. For good measure, I'll change the type to email. Of course, we'll change the placeholder. I don't need to change my onChange. We'll make sure that this name exactly matches the name that we chose in state on our property here. And, well, I believe that should do the trick. I'll hit save, type in a first name, we'll say it's Joe, last name Schmo, joe@schmo.com. And sure enough, our state is updating exactly as we would expect, now maintaining all three of these properties. Now, for those of you that followed my directions a few screencasts ago and actually read through the React Forms documentation, you would have come across a section that talked about controlled inputs. As of right now, our inputs are not controlled, and so in the next screencast, we're going to see one simple addition we can make to turn them into controlled inputs, and we'll talk briefly about what a controlled input is in the first place. A term you might hear floated around as you're learning about React is something called controlled components. Again, if you read through the React Forms documentation, you'll have come across the section called controlled components. If it's been a minute or you didn't have a chance to read through that, you can click this slide in order to go directly to that documentation. But when we're talking about maintaining state inside of a component, there's a common concept called the single source of truth. The idea is that the state that you're maintaining in your component should be the single source of truth. If you think back to when we were learning about changing state and we had our boxes or squares example, one solution we came up with was allowing each box to take the incoming on prop and then set its own internal state based on that incoming prop. And then the box itself could change its own internal state and therefore display either being filled in or not filled in. If it's been a minute since you've seen that lesson, of course, you can always go back and watch that to refresh on what I'm talking about here. The problem, as we learned then, is that we have two instances of that state that exist, and they don't necessarily match up. In other words, there isn't a single source of truth. The array of these objects was being held in state in the app component. However, each box was then changing that state essentially without telling the app component that it was changing, and therefore there was state that oftentimes would not match with one another. We have a similar concept happening here, where in the markup inside of our inputs, each of these inputs in effect is holding its own state. Think how in a regular HTML form, no React involved at all, when a user types into an input box, essentially that input box is maintaining its own state. Well, in this case, we have two pieces of state. One is being held by the input box just in regular HTML, and the other is updating on every keystroke held in our React code. Of course, we have set it up so that the state of our input box then perfectly gets mirrored by our state in React. However, a good practice in React is to make it so that your React state is what drives the state that's visible inside the input box. I totally understand this might seem like I'm splitting hairs here, but if it helps, all this really boils down to is simply adding a value property to each one of our inputs. So here at the bottom of each one, I'll add value equals and then a set of curly braces. And then all we need to do is add the piece of state, in other words, form data dot, and then the name of that specific input into that value. So we'll add form data dot, and then in the first one, I'm going to have first name, last name, and email. Visually, we're not going to see any difference here. Conceptually, however, when I type into the first name, Bob, the value of this input box is no longer being controlled by the input, but rather by React. Every change that I make runs my handle change function, which then updates the correct piece of state, which re-renders my form, and it sets the value of my form input to be whatever state is. So now state is in the driver's seat, telling the input box what to display, rather than the input box telling the state what to be. The main reason to learn this about controlled components is because sometimes if you don't set this up correctly, React might sometimes complain about having uncontrolled components. Fortunately, the concept itself is more difficult to understand than actually implementing it, so if you don't feel like diving deep into understanding controlled components, honestly, that's going to be completely okay at this point. Just remember that you need to set the value of your inputs to be equal to your state that represents that input value. There are a few more small things that we need to learn regarding forms. So at this point, we're going to speed through some of those so that we can get to a challenge that will help you practice all of this together. If only all form elements were as simple and designed the same way as the inputs that we've been working through, these text-based inputs, then our life would be so much easier. However, forms have more variety in the types of inputs you can have. For example, radio buttons and checkboxes, text areas, and so forth. Each one of these has some special considerations we need to keep in mind when we're using them in React. To start us off, let's look at the text area element. In regular HTML, text area is a little different than an input because it is not self-closing. It has its own separate closing tag. And in HTML, whatever you put inside the opening and closing tags is the value of that text area. You'll see I'll hit refresh and we get a text area that's a little bit larger. We can also set the size with rows and columns. The user can make this bigger or smaller if they need to. However, what the React team has done is they've chosen to make the text area much more similar to a text-based input. And so they've taken the closing tag away, they've made it a self-closing element. And just like our inputs, we will now add a value property to it, and that's going to be the value that's inside of the text area. Once you understand that they've changed the text area to be a self-closing element, essentially everything else we've learned about text-based inputs remains the same. I suppose in the text area case, we're probably not going to include a type because the text area is sort of its own type already, but everything else should essentially be the same as our inputs, which means that it's time for a challenge. Okay, your challenge is to add a text area for comments to the form. We do want to include these comments in our state as the user is typing into the text area itself, so make sure to update our state as well. Pause the screencast, work on this challenge. While we're up here with our state, I'm going to add a comments property to my state object and initialize it as an empty string. Then at the bottom of my form, I'll render a text area element. Again, it's self-closing. And just like the other ones, we will put a value in here that will be formData.comments. That way it can be a controlled component. We'll add a placeholder that just says, let's just say comments. We'll use the same onChange handler, so we'll have handle change. And in order for handle change to work, we need to make sure we assign the same name that we have in state. So comments and comments. Now I've added some styling. I did that directly to input, so my text area isn't going to be styled that way. Maybe I can get lucky and just add text area directly to my styles here. Let's hit refresh. And okay, well, my height's a little funny, but that's something I could always change later. Let me add a console log here so I can make sure that it's hooked up correctly to state. We'll just log formdata.comments to make sure that just that one piece is coming in. Okay, awesome. Oh, I guess those styles aren't really going to work out because it's doing that text indent thing. That's kind of silly. Let's just put this in its own thing. Okay, that's a little better. Awesome job. The next form element we'll talk about is checkboxes. Let's take a look at the checkbox element. Now, checkboxes aren't just an HTML element on their own called checkbox, although to be completely honest, I kind of wish they were because that would just be a lot easier. But no, they are an input with a type of checkbox. Checkboxes are fundamentally different than what we have been working with so far with our text inputs because they just hold Boolean values. In other words, there's not going to be some kind of string text of my checkbox. Instead, there is a checked property that will either be true or false based on whether the user has checked the box or not. Before we jump into checked, let me clean up my input for just a second because right now I just have a bare box sitting here. While I was cleaning up this checkbox, I was reminded of something that we haven't yet talked about, and that is this HTML4 property. When we have something like a label that is supposed to be tied to another input, you have a couple options. You could nest the input directly inside of the children of the label. What that does is if the label gets clicked, it will automatically propagate that click down to the input. However, my personal preference is to keep the label as its own separate element and then point that label using HTML4 to the ID of an input so that they can be associated with one another. In plain HTML, you're probably used to using just for, but if you were to look under the hood at the underlying DOM element, it's really called HTML4. That's the JavaScript property for that element. Anyway, that's a digression. So now we have a checkbox that asks the person if they're friendly or not. And we want to maintain this in state. Well, because it's a checkbox, we're not maintaining a string. So up in state, I'm going to add another piece of state and actually start separating these onto their own lines to save some space here. And we'll call it is friendly. And just to give them a benefit of the doubt, we'll call it true as the default. As I briefly mentioned, to associate our state is friendly with our checkbox, we're not going to use something like a value property, but instead we're going to use a checked property. Now, because a checkbox is either checked or unchecked, the value that we put in here for checked needs to be a Boolean, or at least whatever you put in will be interpreted as a Boolean. So if I put something truthy in like the string hi, it's going to check the box. If I put in something falsy like an empty string, it's going to not check the box. But in the end, that doesn't really matter because this should be a Boolean value. So I'm going to say formdata.isFriendly. Now, when I hit refresh, do you think that this checkbox will be checked or unchecked? It should be checked because our default value is true, right there. So when we say this box is checked, we are having React dictate to the box that it is checked, in fact, because that's what state is. Of course, now we've introduced a bit of a bug. I can't uncheck the box. Maybe that's a good thing. For this specific form, we don't want people to be unfriendly. But for the sake of argument, let's say we want this to act like a normal form. If we look closely at our handle change function, we have only been looking at event.target.value. However, with a checkbox, we are not looking at the value property anymore. We're looking at a checked property. So, of course, I could go out of my way to create a completely separate handle checkbox change function, but we can do better than that. Let's assume for now that we can reuse our same onChange function. We'll put in handle change as our onChange. And then let's go up to our handle change and we're going to make some modifications here. The first thing I want to talk about is a best practice that we should be following, and that is not to put the entire event.target.value and event.target.name down here inside of our set form data. At this point in the course, it's not that important that you understand why we're going to do this, but a much better way to handle this is to destructure event.target and pull out the values that we need. So we need name and value from event.target. And then I can switch this to name and switch this to value. And then, as I mentioned, when we're handling a checkbox, there's a few more things we need to pass in. One property that will come in is this type property on all of our inputs. We have a type text, email, and down here, our type of checkbox. So let's bring in that type so we can check whether or not the input that's making this handle change function run is a type of checkbox. And if it is, we're also going to need the checked property. And this is either going to be true or false, depending on how the user has interacted with the checkbox. Now comes a bit of a trick. When I'm setting my form data, I want everything else essentially to be the same. However, the piece of state that I want to update, if it's a checkbox, in our case, the isFriendly property, should not take on value, but rather should take on the value of checked. So I can use a ternary here that says, is the type equal to checkbox? If so, I want you to use the checked property. But if not, I want you to use the value property. Let me get rid of this console log because that's from a previous screencast. Let's refresh. We'll hit the checkbox and oh no, there's a bug. So I'd like you to look at the input that we've created, perhaps compare it to some of the past inputs that we've created, and see if you can figure out what we're missing. All of our other inputs have a name property, and that's something that I simply forgot to add in. So I'm going to add a name. This needs to match exactly what is in state. We'll say isFriendly, and that way, when I hit refresh, I should be able to now check the box. Awesome. This is probably a good time to mention that everything we're learning here with forms can be really confusing and especially hard to try to memorize. Honestly, as I've been preparing this lesson, I've had to go back to some of my old notes and some of my own recordings to remember what the syntax for this actually looks like. So just think of this as a pep talk. Now, if as I'm teaching it, you're still feeling totally lost and it's not making any sense at all, that's a cause for alarm. You should be able to generally follow along, but in this case, I'm not necessarily going to quiz you on the exact syntax for everything because, well, it's just as easy to look it up if you really need to. Okay, so let's get back on that horse, and we're going to next look at radio buttons. In React, radio buttons are kind of an interesting combination of checkboxes and text inputs. I'll talk about what I mean in just a second, but in the meantime, I've put together this field set that asks about our current employment status. To skip some of the mundane stuff, I've already added the type of radio and some IDs in order to associate the labels using HTML4 with the correct inputs. So now let's talk about how we can hook these radio buttons into our form and connect it with our state. First, we need a place in state to hold all of this information. I'll add another property to our state called employment. And where checkboxes are either true or false, radio buttons, similar to inputs, will have some kind of text value to them. In this case, I want employment to be some kind of string, either unemployed, part-time, or full-time. So on a high-level overview, what will happen is when the user clicks one of these options, we will be watching for changes in these inputs, and when a change happens, it will take the value of that specific radio button that was clicked and set our state to that value. In order to associate my inputs with the correct piece of state, and also to make it so that I can't click all of my inputs the way I can now, I need to add a name property to each one of these inputs. Like we've done before, I'll set the name equal to employment, which exactly matches the property that we are saving in state. The reason we're giving the same name to all three of these radio buttons is, first of all, in HTML, that's the way that we make it so only one of these radio buttons can be selected at any given time. But it also intuitively makes sense because we're only updating one property of employment based on which one is selected. Each one of these inputs will have its own unique value, and this value is what will actually get saved as the value in state when this specific input is selected. So for the unemployment or the unemployed one, I'll put unemployed. For part-time, we'll use part-time. And for full-time, we'll use full-time. Next, I need to make sure that I'm listening for change events. So I'll add my onChange of handle change. Believe it or not, we'll also be able to use the same handle change function, and we'll see why in just a minute. And technically speaking, this should now be hooked up correctly to state. I can test that by coming up here and console logging my state. We'll just console log the employment part of it. So we'll say console log form data dot employment. If I hit refresh, we get an empty string, and then when I choose unemployed, it switches to unemployed, part-time, and full-time. There's one more small thing that we need to change, and it's essentially mirroring what we did when we were setting our value equal to the state. Radio buttons are a little different because we need to specify what value the state should take on if the radio button is selected or checked. However, that means that we can't do controlled components in the same way that we did with our inputs by setting the value equal to whatever the current value of state is. But that doesn't mean we can't control these components. It's just that radio buttons are controlled in the same way that checkboxes are controlled. Here we were able to say checked equals formData.isFriendly. However, if we try to do the exact same thing with our radio buttons, we're going to run into a little bug. We'll see that here. I'll say checked equals formData.employment. And when I click one of them, well, some weird stuff is happening. This is where radio buttons differ from checkboxes in that when we are controlling the checked property, we don't simply say checked equals formData.employment because, unlike a checkbox, this is not a Boolean value, but we can make it a Boolean value by checking if the formData.employment is equal to the value of this specific checkbox. So I'll do the exact same thing over here. And now React is in charge of controlling this input rather than the input having its own HTML state. Let me walk through that one more time. Let me hit refresh. Initially, the value of formData.employment is an empty string. When I click unemployed, it runs the onChange for handle change, which we have defined here. We're pulling the name, value type, and checked out. We're setting the form data. We're bringing in all the old form data. Now we're using name, which we had set to employment, as the key for our state that we're updating. And it looks here, says, is the type checkbox? In reality, no, this is not a checkbox, it's a radio. And so it skips the checked value and instead uses this value. This value is the value that we defined here, where we said it's either unemployed, part-time, or full-time. Then when we change state, React re-renders our form. It checks to see if the current formData.employment is equal to unemployed. In our case, since that's the one we chose, then that becomes a true statement, and therefore checked is true, and all of these other checks are false. That makes it so that only one of these can be checked at any given time. In my opinion, radio buttons are probably the most confusing element to deal with in React, so if you have understood everything we just walked through, then kudos to you. Truly, this is a big accomplishment. So you really should be proud of yourself. Again, you don't need to have memorized this necessarily. You can always come back to this lesson or find something on Google to help you through the syntax of this if you need it again in the future. But if you were able to follow along with the logic that we just talked through, then that really is a good signal that you understand state, you understand event handlers, and some of these little quirks about forms in general. There's one more form element I want to talk about before we move on, and that is select boxes, and we'll do that in the next screencast. The last form element we're going to talk about in React is the select box with its options. In regular HTML, it's usually set up something like this, where you have the select box. I've added an ID just so we can associate our label with it, and it has a number of options inside with a value for each option. In regular HTML, in order to grab the value of whichever one is selected, you will look for a property called selected, although that would happen in the JavaScript. But all of this is a bit beside the point because React has decided to make it a lot more similar to some of the other input elements that we have seen so far. So just like we've done with some of the other elements, we are going to add a value property here on the select itself. And this value, similar to our text inputs, will just mirror what we have in state. Now, currently we're not saving a favorite color in state. So let's go ahead and add fav color. We'll start it off as an empty string. And then down here in our select, we will say formData.favColor. We can reuse the same onChange handler that we've been using with handle change. And in order for handle change to work correctly, we need to make sure that we mirror our name to exactly equal the property that we're saving in state. So at this point, I should be able to click my dropdown, and you won't see this dropdown in the recording, but if you click onto this app and hit the refresh icon, you can test this out for yourself. I'll click the dropdown and I see the different colors: red, orange, yellow, green, blue, indigo, and violet. I can choose green, and that will change our dropdown to green. And actually, let's go up here and change form data employment to console log our favorite color instead. So that way, whenever I make a choice like green, our state is updating according to the value of the option that was chosen in this dropdown box. Now we do have one little issue here. If I hit refresh, we see that I'm initializing state as an empty string for the favorite color, but currently I don't have an option that represents the empty string value. One way I can change this is by providing a new option where the value is an empty string, and then maybe I put in something like choose that makes it so that the user will see choose here on the first option. I'll hit refresh. We see choose as our option, but I can still drop this down and change it to any of these other colors, just like we would expect. And that pretty much does it for any of the form elements that we're going to be talking about in this course. There's one last small thing we need to cover about forms, which is how to submit a form. And so that's what we'll cover in the next lesson. Now that we have a way to gather all of this information from our user, we need to be able to submit the form. In HTML, you might be familiar with an input of type submit. An input type submit is, well, basically just a button. And of course, the default option there is submit. We can change the value to something different, like, I don't know, send it in or something. Okay, and that changes the text of the button. Let me put a couple breaks here just to move that down a bit. However, in HTML5, they made it so that the actual button element, if it's found inside of a form, acts like a submit button. What's nice about the button element inside of a form is that you're not doing this weird value thing, because it's not really a value, it's just the text of the button. So I could just put submit here, and because this button is found inside of a form element, its type is actually automatically submit by default. In fact, if you didn't want it to act like a submit button, you'd have to actually change the type to button, which looks kind of funny, button type button. So let's just make use of that default. We'll get rid of our type completely, and therefore the default is type submit. And clicking this button, because the button is found inside of a form, will actually trigger the form's onSubmit event handler. Now, back in the day, instead of having a JavaScript onSubmit handler, you might have something like a method that tells you this is going to be a post request, and you'd have an action that probably led to some PHP file.php, and then PHP would take the data and process it, do whatever you needed to do. However, we're going to essentially bypass that entire system. We're going to set up the onSubmit event handler, and let's create a function called handleSubmit. And up here, I'll actually create that function. And what's nice about the way we have set up our form in React is now, instead of having to go through every one of our inputs and gather the values right at the last second before we submit this to maybe an API, we've been doing all that work all along as we've been updating state on every change of the inputs and elements in our form. So if we pretended that we had some kind of submit to API function, we would really just be able to probably pass our form data object into that function because it's already updated. It's been updated after every change of the form. Now, just like in vanilla JavaScript, if you have built a form and gathered the data in JavaScript, you know that clicking this submit button will actually refresh this page, and it'll put all of the form values as part of a query string in the URL. That all harkens back to the original way that forms were submitted with an action property. So the first thing we will always want to do in React when we're handling a form submit is to take that event object that will get passed to this event handler and run event.preventDefault. Preventing the default means that it won't refresh our page and essentially re-render our app with all of these default values and state. Prevent default just stops all of that from happening and makes it so that we can then run code the way that we actually want to. Just to see this working, I don't actually have a function called submit to API, so let's just console log our form data. So before we test this out, let me remove some of these console logs so we can actually see what we're working with. I'll hit refresh, type in some generic values here. Okay, and we'll hit submit, and we can see we got our state object. Everything has been automatically updating as we've been typing things into our form. And maybe just to drive the point home, let me comment out this prevent default, and I'll type in some stuff here and hit submit. And you can see my form refreshed and then my URL actually updated. I'm not sure if that comes through in the recording, but this is the URL, and it took all of my values based on the name property, stuck it as query strings in the URL, and it's just not what we want to do. Okay, with all of that behind us, I do want to get your hands on the keyboard practicing some of the things we've learned with forms, so that will be what we do in our upcoming challenge. Okay, we've covered a lot of ground, so before we move on, I want to test your skills and your knowledge, make sure you were paying attention. So with this quiz, pause the screencast, click into the editor, type down your answers, and when you've answered all the questions, click play and we'll go over the quiz together. Number 1, in a vanilla JavaScript app, at what point in the form submission process do you gather all of the data from the filled out form? All of that data gathering happens right when the form is submitted. Or I should say right before the form is submitted. Usually you listen for the form submit event, and then you'll go to each one of the elements in the form and gather the data. So in number 2, it asks basically, how is that different in a React app? Well, in a React app, we're basically not allowing the form elements to maintain their own internal state, but instead, the component that houses the entire form has some React state, and that state is updated on every change of the elements in our form. So for a text form, it's every keystroke that the user types into their keyboard. For a checkbox, it's every time the checkbox changes or the radio buttons change, and so forth. So in short, we gather all the data as the form is being filled out. And of course, all that data is held in local state. Number 3, which attribute in the form elements, for example, the value, name, onChange, etc., should match the property name being held in state for that input? Well, it's the name property. Essentially, we use that name property to help us in our onChange so that we know which property in state to update whenever a change happens. Number 4, oh, that A should not be there. What's different about saving the data from a checkbox element versus other form elements? In all the other form elements, we're using the value property to know how we should update our state, but with a checkbox, we're looking specifically for the checked property. Okay, and number 5, how do you watch for a form submit and how can you trigger a form submit? Simply enough, we can add an onSubmit handler on the form element. That's how we can watch for a form submit, and we will pass a function to the onSubmit handler that will run whenever the form is submitted. So then how do you trigger a form submit? Usually that will happen with some sort of button click. As a quick reminder, in the markup, if you have a button element that's inside of a form, it will automatically act as a submit button for that form. Alternatively, and what kind of seems like the older way to me, is to use an input type submit. But to me, there's not really a benefit to doing that. Okay, awesome job on this quiz. Hopefully you were able to answer all these questions. Next, we're going to put what we've learned about forms into practice. In this challenge, your job is to connect our existing form to some local state and update that state whenever the user interacts with the form. As we've been doing, I want you to make sure that you only create a single handle change function that can manage the state of all 4 of these inputs: the email address, password, password confirmation, and the newsletter checkbox. Then when the user clicks sign up, you'll run through some logic that makes sure that the password and password confirmation match each other. And if they do, you should log successfully signed up to the console. And if they don't, you should say passwords do not match in the console. Additionally, when the form submission happens, I want you to check if the checkbox for the newsletter was checked, and if so, log "Thanks for signing up to our newsletter" to the console. If not, don't console log anything. There was a lot of syntax that we learned when we were going through the different pieces of the form, so don't be afraid to open up in another tab some of the previous lessons that we've gone through as a reference. So pause the screencast and work on this challenge. All right, let's do this. I'm going to start with some state. I'll create state called form data and set form data using react.useState. That will begin as an object, and I can provide this object some default values. Let's have an email property that's empty, a password property that is empty. We'll call this password confirm. And let's say maybe joined newsletter. This one will be a Boolean because that's what checkboxes deal in, is Booleans. And so we'll default it as false. Or maybe if we're good marketers, we'll default it as true. And then what we can do is add these properties as a name field in each one of our inputs. So we'll add name equals, and then we'll put exactly what those properties were from up above. While I have all of these selected, I'm going to add an onChange for every one of them that will point to a function that I'll create called handleChange. And then we'll also give a value property, and I'm going to change this on our checkbox because that should be checked, not value. This way they can be controlled elements or controlled inputs, and I will make sure that we're pointing form data dot, and then we'll paste in the values that we copied above. Let's fix our checkbox. So this should say it's checked if form data dot joined newsletter is true, or not checked if it's false. And now let's go create our handleChange function. From the event, I'm going to pull out the name property, value property, type, so that we can check if it's a checkbox that made the change, and the checked property. We'll get all of those from event.target. Target represents the element that was modified in the event. Then I can run my set form data function, and I need to access my previous form data. So we'll say prev form data, and this will be the parameter to my callback function. And I'm going to use that little trick where I can return an object by surrounding it in parentheses. That way I can make use of the implicit return without having to open the body of this function and then use the return keyword and so forth. And so I'm returning an object, and that object should have all of the properties of the previous form data, but then I want to update the property based on the name value that we pulled from the input that is making this change. That's using this computed property syntax. And the value would normally just be value if I didn't have this checkbox here, because all of my other inputs are updating a value property on the input itself. However, because I do have the checkbox, I'm going to check if the type is checkbox. And if it is, then I want to set the checked property of that checkbox. That's what's going to either be true or false based on whether the user has checked the box or not. If the type is not a checkbox, then we can just use the value property to update our state. Let's do a quick check before we get to the handle submit part of the challenge. I'm just going to console log my form data, and let's see if updates happen. Well, it's good to see that my checkbox is automatically checked, because that means that it's connected correctly to state, and our default was set to true. So if I uncheck it, we get false. That's good. Email address, password, and confirm password. Cool. Everything seems to be connected the way I would expect. So we can get rid of this console log to clean up our logs down there. At this point, all that's really left is some vanilla JavaScript logic that we need to write inside of our handle submit. And hopefully when you were doing this challenge, you noticed that I already set up our onSubmit to run the handle submit function. And because our button is inside of the form element, it acts as a submit button automatically. So clicking the sign up button will trigger the submit event on the form, and therefore we'll run the handle submit function. And well, I accidentally deleted the event.prevent default. I don't want to delete that. I need that. Otherwise, submitting the form will submit it as if it were submitting to an old PHP or backend, which would then take all of these values and submit them as query strings in the URL and refresh the page and everything. Essentially, I just don't want to do any of that. So event.prevent default is always going to be the first thing that you'll do at the top of your handle submit function. And yeah, like I mentioned, we just have some vanilla JavaScript logic to work through. So if the password and the confirmation match each other, we need to log successfully signed up. So I can just say if formdata.password is the exact same as formdata.passwordconfirm, then console log successfully signed up. And in any other instance, we will console log passwords. Oh, this says to not match. That should say do not match. Passwords do not match. And then separately, we can process the data for the newsletter. And if formdata dot, let's see, what was it called? Joined newsletter. If that's a true value, then we will console log. Thanks for signing up for our newsletter. Okay, let's give this a test. I'll open my console, put in an email address, password, confirmation that is matching, and we'll have the checkbox checked. I'll hit sign up, successfully signed up, and thanks for signing up for a newsletter. Let's say I change this password to something different. Passwords do not match. And well, you know what? That leads me to something that I didn't mention in the challenge, but probably would make sense to do. If the passwords do not match, I don't want to make the person think that they signed up for the newsletter. So I think I'll just put a return right here after my passwords do not match so that this if statement never gets run in case they don't match. Let's try this again. We'll hit refresh. And we will make the passwords not match. Hit sign up. And we just get passwords do not match. Okay. Then if we do make them match and we uncheck, we get successfully signed up without the thanks for signing up to our newsletter. Awesome. Obviously, we didn't touch on every aspect of forms that we've learned about, but a form like this is a lot more common for you to develop than something that has every kind of form input under the sun. Awesome work on this little mini section on forms. Believe it or not, we're really rounding the corner, almost at the finish line for this section. We just have a few more things to learn before we can really tie together the remaining aspects of our meme generator project and finally tie a bow on that and call it complete. So when you're ready, let's jump right in. Now that we've learned how to save input data from text fields into state, let's revisit our meme generator and get it to an almost complete state. We created earlier the top text and bottom text fields, but they're not hooked up to anything right now. So your task is to connect the inputs into state so that every keystroke, they update the top text property in state and the bottom text property in state. Now, I've done a little bit of CSS heavy lifting for you, and that's because I really want to focus on the state part of React right now. But in short, I've added a wrapper around our image so that the whole thing is considered the meme. I made that meme a position relative so that I could set the H2s to be position absolute. This meme text is styling it to look kind of like a classic meme text. And the top and bottom classes simply stick it at the top or at the bottom of the container element. And as you can see down here, I've hard-coded the top text and bottom text, but part 2 of your challenge is to replace that hard-coded text with the text that we are saving in state. Pause the screencast and work on this challenge. I think the first thing I'll do is add the properties that I need to my inputs so that I can be watching for changes. Let's add a name property to each one. Say name equals, and then we'll have, this one is our top text, and this one is our bottom text. Next, we'll add our value properties so that these can be controlled components, and those will be meme dot, and then top text for the top one, and bottom text for the bottom one. And then we're going to need an onChange event handler. We'll call it handle change, and then we'll create that function. I'm going to pull in the event so that I can get the name and value properties from our event. So I'll just destructure those now. And that's going to be from event.target. And then I will essentially be doing exactly what I did with getMemeImage here with setMeme. I'll type it out for the practice. We're going to set the meme, and I do need access to the previous version of the meme. I need to return an object, which if I want to do that as an implicit return, I need to wrap my object, my curly braces that represent an object, in parentheses so that it doesn't think I'm just trying to open up the body of the function. And we'll copy over all the properties of the previous meme, and we will change either the top text or the bottom text property depending on what name gets pulled in from the target. So I'll use that computed property name and set its value to value. Lastly, I will update my hard-coded text to look at our object values and state. So this will be meme.topText and meme.bottomText. Okay, let's cross our fingers. I'll hit save. One does not simply walk into Mordor. Ain't that the truth? Now, it's kind of like playing roulette here. If I click get a new meme image, it's probably not going to work out so great, but we'll see that our text is staying on top and on bottom. And switching the meme image can actually be kind of a fun exercise because your text may or may not apply to the new meme image very well. Awesome work. This is super exciting. Basically, our meme image is sort of at an MVP, a minimum viable product, to push this out to our customers. In reality, we are still importing our memes data from a JavaScript file when what we really want to do is get that from an API. There's a few more things we need to learn in order to do that successfully, and that is what we're going to start talking about in the next screencast. A very common thing you'll need to do in React is interact with an API that lives outside of your application. Usually what you're doing is either requesting information from an API or sometimes submitting information to an API. Whenever you're requesting information from an API in React, usually you want to display or use that information somehow. So getting data from an API in React consists of essentially two parts. First of all, you need to get the data. And that would be using something like Fetch or another tool for getting data like Axios. The second step would be to then take that data and save it to state. Once it's saved in state, your application can interact with it, it can display it on the screen, and all of the other benefits that come with saving something in state. So let's see some preliminary syntax as to what that might look like, and then as a spoiler alert, I'm going to show you why this is broken to do it this way. To start us off, let's do a fetch request to the Star Wars API. This is just a very simple API that will get us some information about Star Wars characters and planets and movies and stuff like that. I'll go ahead and resolve the promise that I get back from fetch. It will receive a response, which will be JSON. I want to turn that into a JavaScript object that I can use. And then with that data, we'll just console log the data for now. Okay, awesome. We have this object here. I'm not going to bother digging into this object. I'm just going to stringify the entire thing. So let me put that into state. And you know what? I'm actually using data in a couple places. Let's maybe call this Star Wars data and set Star Wars data. And then instead of console logging, we will set Star Wars data with the data that we get back. And then I need to make sure to update down here as well. Let's hit refresh and see what we get. Okay, there's the data from my API. Awesome. Everything seems to be working swimmingly. However, let me illuminate something that's going on behind the scenes right now. I'm going to console log component rendered. Every time the app component renders or re-renders by React, it will run this console log. So let me open my console, hit refresh, and look at this. We've got an infinite loop of component rendering. Let me comment this out and hit refresh. Now, I want you to pause and think for a second, why was this console log running over and over and over again? Pause now and see if you can come up with an explanation for why it was doing that. The reason we were stuck in an infinite loop is because this fetch lives on sort of the top level of our component. Because of that, anytime the component renders, it's going to call fetch. And every time it calls fetch, it's going to set the Star Wars data, which is updating our state and therefore causing React to re-render this component. And then it's running fetch again, setting the state, re-rendering the component, calling fetch again, setting the state, re-rendering the component. I think you get the idea. In fact, even though we're not seeing that happening with this console log commented out, it's still being re-rendered in the background. So I'm going to comment this out so that it actually stops re-rendering. And in fact, the only thing we really need to comment out is where it says set Star Wars data. When we had a console log here, I'll uncomment this component rendered and open my console. We'll see that we're no longer in an infinite loop, and that's because we're not setting state, causing the component to re-render. So this acts as a perfect springboard into the next topic that we're going to learn about, and that is how to handle side effects in React. So that is what we will tackle next. We're now embarking on a journey that leads to oftentimes considered one of the most confusing parts about React, and that is how to manage side effects. To really understand what I mean by side effects, let's take a look for a second at what React's primary tasks are. First of all, React is in charge of working with the DOM and the browser to render some kind of user interface to the page. The React team has created a really simple interface to allow us as developers to accomplish this with JSX and elements that look just like HTML. Under the hood, of course, React is taking that JSX and turning it into elements that can be displayed on the page. Another task, which we have mostly been learning about in this section, is to manage state for us. And if you think carefully about it, it's managing that state between the render cycles. In other words, React can remember state values from one render to the next. So that's another thing that React does, and we are allowed to hook into that state using the useState hook. And then naturally, its next task is sort of a combination of these two. It needs to keep the user interface updated whenever state changes. There certainly are other tasks that React is accomplishing, but you can probably boil the main three tasks down to these three. So then what is React not able to handle on its own? The major one that we're going to be discussing is any kind of side effects, or I put outside effects here. All that really means is anything that lives outside of React's purview or reach. So some examples of this are local storage on your own browser, for example. We can of course use code to access local storage, but React has no real hand in interfacing with local storage. Along that line, any kind of API or database interactions that occur in our code, we can write that code to interact with APIs, but React is not in charge of that code. Or rather, React has no way to know which APIs we're going to be reaching out to. Similarly, any kind of subscriptions you might have, if you include WebSockets in your application, for example, you have a chat application that updates live. And as it turns out, even if you have two different pieces of internal state that you need to sync together, or have one of those pieces of state react to a change in another piece of state, React can manage the state of each one behind the scenes, but it's not really looking at any kind of crossover between those two states. So in the end, it boils down to basically anything that React is not in charge of can be considered a side effect or an outside effect. So using this API interaction for an example, if we look at our code from before, I commented it out so that it wouldn't keep infinitely rendering, we can see that React is essentially just doing what it's told. It's trying to put something on the screen, it's trying to manage state, and it's trying to keep state and the screen in sync. If state ever changes, it needs to re-render the component. As a side note, if this were receiving props and somehow those props were also to change, for example, if those props were a piece of state in a higher up component that then changed, this component would also re-render. So with our code living here on the top level of our component, React really doesn't have a way to stop us from setting the state here, causing the re-render, which would then set the state again, causing the re-render, and so forth in that infinite loop. So the React team gives us a really nice hook called useEffect. In the documentation, this is called the effect hook. And I like to think of it as a tool that React has given us developers to use sort of like a blank canvas that allows us to interact outside of the React ecosystem, which again mostly just consists of state, props, and the user interface that it puts on the page. And I like to think of useEffect as being a tool that allows us to synchronize React state with those outside systems like our local storage or an API. Now, before we jump in, I've included here a link to the documentation. If you click this slide, you will be sent to this page where you can learn about using the effect hook. Again, think of it kind of like reading the textbook before coming to class. Now, you don't have to scour every single word in the documentation, but I do want you to take a look at it, read through it, and then when you've got a cursory understanding of the effect hook, then we'll jump into the next screencast. As you're reading through this documentation, you'll run into a line that says, if you're familiar with React class lifecycle methods, you can think of the useEffect hook as component did mount, component did update, and component will unmount combined. So if you are familiar with class lifecycle methods, I actually want to implore you not to consider this tip. If you have no idea what I'm talking about, then that's totally fine. You can forget everything that I just said about class lifecycle methods. But if you are familiar with class lifecycle methods, the modern advice these days is not to try and think of the useEffect hook as a combination of these lifecycle methods, but rather to work on retraining your approach to understanding side effects in React. I know that might be strange for me to be contradicting the documentation, but I know that I'm backed up because this is an article by Dan Abramov, who is one of the core contributors to React, and he writes this giant blog post about understanding useEffect and essentially goes in depth into how we should not be thinking of useEffect as a way to hook into lifecycle methods, but rather as a way to deal with side effects in React. If you really want a deep dive, you can click this slide to go to this page. But if you're learning React for the first time, you do not need to go this in-depth into useEffect at this time. So once you've had a chance to skim through the React documentation on the effect hook, let's jump in and start learning how to manage side effects in React. Let's begin refactoring our code here to use the useEffect hook. Just as we can access the useState hook on top of the React object, we can do the same with useEffect. So I can create a side effect by using react.useEffect. And useEffect has one required parameter and an optional second parameter. In this screencast, we're just going to learn about that first required parameter, and in the next one, we'll talk about the optional second parameter. The required first parameter for react.useEffect is a function, a callback function. And maybe so that's perfectly clear, I'm going to write this out as a function declaration. Although in practice, you'll almost always see this as an arrow function, and that's what we'll eventually transition to as well. And this function acts as a place for us to be able to put our side effects code. In the little example we have here, this fetch request is considered a side effect, and that's because it's reaching outside of React's ecosystem, but also trying to set some state in the process. Remember, this was infinitely looping because on the top level of our component, it was running this fetch and setting the Star Wars data, which was modifying state and therefore re-rendering the app, which then just ran all the code again in this infinite loop. So let's move this fetch request inside of our useEffect, and that's it. Inside of the callback function that we provide to useEffect, we're allowed to put our code that has other side effects that interact with systems outside of React. And maybe more specifically, interact with those outside systems to keep them in sync with our local state in this component. Now, I do have a confession to make. We're actually only halfway there. If I uncomment my console log and hit save, you'll see that we're still having the same problem we were having before, where we're stuck in an infinite loop. Let me comment this line out so that it doesn't keep setting state. So what exactly is going on? I thought useEffect was going to fix this problem. Well, it turns out that the code we put inside of this callback function, if we don't provide a second parameter to our react.useEffect function, then there's almost no difference between putting our code inside of useEffect and putting it outside of useEffect on the top level of our component. There is one small difference, and that is anything that we put inside of this callback function is guaranteed to run only after the user interface has been painted to the screen. In other words, only after React has taken our user interface, our elements, and created real elements on our page. So this callback function is guaranteed to run in a specific order only after this has been placed on the DOM. But for our purposes here, there's basically no difference. We're still stuck in an infinite loop. So in the next screencast, we're going to start diving into useEffect and understanding first why we need to provide this second parameter, and then what that second parameter is and how it solves this problem. I've made a couple modifications to our app here to try and demonstrate exactly what's happening within useEffect. I came up with the simplest little counter app that just has a single button that says add and something that displays what the current count is in state. The reason I did this was just to make it so that we had a really easy way to trigger re-renders and state changes on our app here. I also replaced our useEffect callback function with just a console log that lets us know that this effect function ran. You can already see what's happening down in the console, but if I refresh the site, we'll first get the component rendered console log, and then we get the effect ran console log. As we talked about before, the function we pass to useEffect will run after every render of our component. It essentially makes it no different than moving our console log outside onto the top level of our function, just like we have here. Which means if we ever wanted to change the state within our useEffect, we get caught in that loop like we've talked about a few times already. Now with my little counter, I can trigger a manual re-render by just clicking the add button, and we can see that when I click the add button, it updates the state behind the scenes, so it changes from 0 to 1, and it re-renders our component now with count equaling the number 1. We get our console log, which rendered because it's a function call here on the top level of our component. It then would have skipped down here and rendered our UI so that it could display the correct count now that count is set to 1. And last of all, it ran our effect, which of course runs after every render. As we talked about, the first parameter to useEffect is this function, but there's a second parameter, which, although I mentioned is optional, is something that you will almost always include. And that is something called a dependencies array. Now, don't let the name confuse you. The concept is actually not too terribly difficult. The array that we pass as a second parameter to useEffect will contain values that, if they change from one render to the next, will cause this effect to run. In other words, it limits the number of times that this effect will run, or rather it determines when this effect will run instead of running after every single render. Now, if I leave this as an empty array, it effectively tells React, I want to run this function on the very first render of my component, but then there are no dependencies to watch and trigger this effect to run again. So it ends up being it runs once when the component first loads, and that's it, never again. We can see this in action by refreshing our app, seeing that we did get effect ran, and then adding to our count. And from here, adding to our count is no longer running this effect. And that's because we have an empty array which is not looking for any changes between one render and the next. Now, if I wanted to run this effect every time count changed, I would have to make sure that my effect knew that count was one of the dependencies that signaled to the effect to run again. So now I hit refresh, it will run once, which is why we get effect ran in the console. And now every time I hit add, I'm also running my effect again. Under the hood, this is what's happening. When I hit refresh, state starts out as 0, and the component will take count and replace it with a 0 everywhere it can find it. So here we have an array with the number 0 in the first index, or the 0 index. Then when I click add, React will update the count from 0 to 1, and it will rerun my function, or in other words, re-render my app component, where everywhere I'm using count is now 1. Remember, this used to say count. Well, the second time around, it changed from 0 to 1, so now it's running this component with an array where 1 is the first index, or the 0 index in that array. Then it's going to look at the last time it saw this dependencies array, and it's going to compare an array with the number 0 to an array with the number 1. Now, I probably shouldn't use triple equals because that's not exactly what's happening here. Let me say, okay, compared to, it's going to compare this array to this array. And if any item in this array is different, then it knows to rerun this function. Now here's a question. What if I were to hardcode an array with the number 0 in here? Let me hit refresh. We can see that our effect did run, but now what will happen when I cause a re-render to trigger? If you need to, you can pause and think through that for just a second. Well, I can click add and we'll see that my effect is not running again. Why do you think that is? Well, with a hard-coded 0 in here, every time the app re-renders and useEffect looks at my second parameter of this array, it's comparing the array with the 0 as the first item in it to an array with the 0 as the first item in it. It's going to see that those are exactly the same values, and therefore it will not run this function. And that's why it's called a dependencies array. useEffect depends on these values to know whether or not it should rerun our effect. So again, when I put count, I refresh the page, count starts at 0, I hit add, count is 1, it notices that that has changed, and therefore it reruns our effect. I feel like I've repeated myself a lot here, but I'm hoping that the concept will sink in the more times you hear it. Okay, it's high time that you get your hands on the keyboard, so let me type out a quick challenge. Okay, it's your turn to write the useEffect. The useEffect should run anytime the count value in state changes, and for now, it's just going to console log something like effect function ran. Pause now and work on this challenge. We can start our effect by using react.useEffect. As a side note, just like we could destructure useState from the import statement up here, we can also destructure useEffect if we wanted to and just say useEffect. In fact, I would suppose this might be the more common way that you'll see it. But just like with useState, I'm going to use react.useEffect just so that it's very clear where useEffect is coming from. useEffect takes a function as its first parameter. Before we had a function declaration like this. However, I am going to use an arrow function because that is how you will most commonly see it. This is just going to console log effect function ran. Now, here's something tricky. Without the second parameter, we know that this function will run anytime the app component re-renders. And right now, the only way we're causing re-renders is by clicking the add button. Let me hit save. I can click the add button and we'll see basically the same thing that we had when we had a dependencies array. However, as I mentioned, there's almost never a reason to not include your dependencies array. There certainly are instances where it may be required, but especially on the beginning end of learning React, you almost always will need to include your dependencies inside this array. If you have no dependencies, remember that means that your effect function will only run once the very first time your component is rendered. However, our challenge specifies that it should run anytime count changes, so let's very explicitly put count in here. And now I hit save. Anytime count changes, we get effect function ran. In the next lesson, let's bring back our Star Wars data and get that displaying on the screen again, but this time without an infinite loop occurring in the background. It's quiz time again. Pause the screencast, read through the questions, type down your answers, and when you're ready, hit play and we'll go through the quiz together. What is a side effect in React and what are some examples? Put very basically, a side effect is essentially any code you want to run that React is not in charge of handling. A majority of the time you can think of that as your code that will have some kind of effect on an outside system. So some examples of that might be local storage, anytime you interact with an API, something like WebSocket subscriptions. However, another example of side effects is whenever you have two pieces of state, two states that you want to keep in sync with each other. So those are the examples maybe to answer the first part of the question. A side effect is any code that affects an outside system. The two states keeping in sync maybe doesn't fit perfectly in with that, but hopefully our examples clarify that a bit. So then what is not a side effect in React? Basically anything that React is in charge of. So some examples of that is maintaining state between one render to the next and keeping the UI basically in sync or displaying correctly with the data, whatever that data might be, whether it's state or props. There's certainly other things that React is doing, but it mostly boils down to these two or three things I think we have in the slides about what its primary tasks are. So yeah, to take our elements and render them to the DOM as well. So we'll say render DOM elements. Okay, number 3, when does React run your useEffect function and when does it not run the effect function? Well, it will always run your effect as soon as the component loads. So that's on the first render of your component. And then by default, assuming we don't pass any dependencies to our dependencies array, like we ask about in question number 4, it will run our effect on every re-render of the component. So that's assuming no dependencies array. And when does it not run the effect function? Well, it will only not run the effect function if there is a dependencies array available, in which case it will not run the effect, when the dependencies in the array stay the same between renders. And maybe I should say when the values of the dependencies in the array stay the same between renders. Okay, that leads us in perfectly to number 4. How would you explain the dependencies array? Well, syntactically, it's the second parameter to the useEffect function, and its purpose is to allow React a way to determine whether it should rerun the effect or not. It ends up being an array of values that when React is in charge of re-rendering a component, it will compare the values in the original array with the values in the new array that the effect is running when the component re-renders. And if any of those values is not the same, it will rerun our effect function. So on a high level, it's simply a way for React to know whether it should rerun the effect function. Okay, awesome job on this quiz. We're really rounding the final corner on this section. We just have a few more things to cover. So when you're ready, let's jump right in. I want to work through together getting our little app back to a state where it can pull the Star Wars data without some kind of infinite loop happening in the background. So I have a small series of quiz questions I'm going to ask. First of all, what will happen when I uncomment this code and hit save? How is my app going to act with my useEffect function set up exactly this way? Make sure to look very carefully through the code here. Don't refresh the app or anything like that. Just use what you have learned so far about useEffect and the dependencies array to figure out exactly what a useEffect that looks like this means. Well, for one, we can see that we're telling useEffect that it depends on the count variable, which means that if count ever changes, it's going to run this function again. And if we look closely in the function, we see that we're receiving the data, but we're just console logging it. We're not currently updating our state with that data. Let's open the console and see if this holds true to what we expect. I'll hit save. The very first time around, it's console logging the data that we got back from the Star Wars API. And then if I change my count, it's logging it again. Not only is it logging it again, it's actually going out to the API and getting the data a second time. So that leads me to the next question in our quiz. The second question is, how will this useEffect be different if I use set Star Wars data instead of the console log? Like before, I want you to pause and look through this code, try to analyze it, and see if you can understand how things will be different now. The main difference, of course, is that we are actually going to be updating our state when we receive that data back. Updating that state is going to trigger a re-render of our entire component. However, that re-render will not change the value of count, and therefore will not change this array from one render to the next, and therefore will not rerun our effect. So let's hit save. We'll see that our data populated. It all happened kind of quickly, but really what happened in the background is our component rendered the first time, which ran our useEffect. If I haven't said it explicitly, useEffect will always run on the first render. That triggered the fetch request to go get our Star Wars data, which eventually set the Star Wars data. Setting the Star Wars data updated state, which caused the component to re-render again. So now Star Wars data is the object that we see. It rendered the Star Wars data as a JSON object to our screen. And then the effect checked to see if the old count still matched the new count. And sure enough, it did. And therefore, it did not rerun our effect. Because it didn't rerun our effect, we did not get our Star Wars data again, which would have caused that infinite loop. If I remove my dependencies array completely, then we're back where we started, where setting the Star Wars data re-renders the component, which runs our function, which sets the Star Wars data, which re-renders our component, and so forth. Now, it is pretty contrived to have a dependencies array that is looking at the count, because if you thought all the way through this, you would also notice that if I scroll down and I click my add button, it's going to make another call out to the API. We don't have a console log or anything like that. I bet if you were to open your developer tools, you would have seen in the network tab that it did make another request out to the Star Wars API, and it did set our data here, which would have caused a re-render. We just didn't notice anything because the data that came back is exactly the same as what we had on the screen before. So that leads me to the third quiz question. What exactly should be in our dependencies array in this case? We can see that our code is not making use of count. Usually what you put in a dependencies array will also show up somewhere in the function. But right now, we're not using count to determine how this function runs at all. So if count shouldn't be in our dependencies array, what should be there? Some of you might have thought that it should be Star Wars data. But if we think through what we've learned about the dependencies array, we'll know that if I put Star Wars data in here and set Star Wars data inside the body of that function, I'm going to get an infinite loop again. Because when I set Star Wars data, it's going to change Star Wars data and it's going to re-render the app, which will then run our effect and we'll end up in that same loop. Assuming I only want this API request to happen when the app first loads, if I leave this empty because there are no dependencies for this to run, then I can successfully set up my effect so that it will just run the API request on the very first render of our component. Now we can see if I hit save, it updates our data. And actually, you know what? Let me put a console log here. I'll say effect ran. I'll hit save again. We get our data. We get the log for effect ran. But now, even updating my count is not running our effect again. I know this has probably been a lot to take in, but I'm glad you've stuck with me so far. I really hope you thought through those quiz questions as I gave them to you. If not, you always have a chance to go back and re-answer those quiz questions. And when you're ready, in the next screencast, we're going to extend this example just a little bit to try and help drill in the way that useEffect is working. We're going to start right off with a challenge. I want you to combine our count with our current URL that we're using to get our Star Wars character so that clicking the Get Next Character button will do the fetch request, but for the next character ID. Right now, it's the character of 1, which, as we can see, is Luke Skywalker. And I've updated our state to begin with 1 because I don't think that there's a character with an ID of 0. So essentially, clicking Get Next Character will increment count, but instead of having a hard-coded 1 in here, it should look at whatever the current count is to make this request. While you're at it, don't forget to consider your dependencies array. Pause the screencast and see if you can get this new feature to work. There should only be 2 small changes that we need to make. One is, instead of hard coding a 1 there, we can add to the end of the string our current count. Now, I prefer to use the template strings if I can, so I'm going to change this to a template string. And then instead of using plus count, I will interpolate the count value inside. Now, if I didn't make any changes to my dependencies array, think for a second, what's going to happen when I refresh and I try to get the next character? When I refresh, my component is going to run, and it will run this effect because it will always run this effect on the first render. Count will be set to 1, and so it will make a fetch request to the Star Wars API where the endpoint is people/1. However, because I have nothing in my dependencies array, nothing is going to trigger this function again. Let me put count back in here, and I need to make sure that I will rerun this effect anytime count changes. So now I'll hit save. After the first render, it went to the API and got the character with the ID of 1. We can even see here it says the count is 1. Then I'll click Get Next Character. The count is 2, and after a little bit, we get our next character, the one with the ID of 2, which is C3PO. So when I click Get Next Character, it updates count. Updating count reruns my function, or rather re-renders my component. The effect then looks at the old array, which was an array with one item with the number of 2 in it, and then it looks at the new array, which is an array with the number of 3 in it, and notices that something has changed, which is then a trigger to run my function again with the new number of 3 as count. We have a couple more things to learn about useEffect before we can check that one off our list. But before we do that, it's time that we go back to our meme generator and we use our new knowledge to apply what we've learned about making an API request and saving that data to state. So that's what we'll do next. All right, we've made it to the very last challenge of the meme generator, and then we'll have completed the project. If you remember, up until now, we've been importing our